Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Today we're going to restore an old DeForest Crosley from 1938. Now, in my own opinion, this radio has one of the nicest looking dials I think I've ever seen in an older radio receiver, and I've been saving these restorations for that special time. And that special time has come, so I'm going to share that adventure with you. Let's get started. This is the DeForest Crosley radio that we are going to restore today. You'll see that I've removed the chassis from this radio because the radios themselves are identical. And the reason that I'm going to restore the chassis out of this one and put it into this case is because this one here, the radio chassis, is much more of a challenge than this one here. This one is in way worse condition, so that gives us more of a challenge to do. And I like the look of this case much better than this one here. Somebody has taken the time to remove all the finish. And what I've done is I put a polish on this, and it really brings out the wood. I think this cabinet just looks absolutely fantastic the way it sits. Hopefully you can see the detail in the wood. It just looks great. So I'm going to restore this chassis with you, and then in the end I'll just move this chassis to this one, and we'll be listening to this chassis in this radio case right here. So this also allows me to show you what it looks like with and without the actual radio chassis in. You can see the nice big original stained area, so you can see obviously the light around it has, I get lightened up the stain a little bit. You can see this is underneath this right here, so this would be the original color under here, unaffected by UV light and everything. And I'll turn this around in a moment. I'll show you the back side here. So this one here has the presets, much the same as this one here. As I say, this is identical to what would be sitting in here. And I can also, manually tune the stations. You'll see the little pointer here move if you keep an eye on that. That little arrow moving down there. And the eye sitting right in the center. This should look absolutely fantastic. So in the end, we'll be listening to some radio stations on this, and you'll get to see the magic eye glowing, and we'll tune in some radio stations. Should be a lot of fun. This is what the backside of the radio receiver looks like with the chassis removed. As you can see, the electromagnetic speaker down on the bottom. We'll take a closer look at this in a little while. And on the top here, there are some rubber grommets that, of course, have long since decayed. I'll talk about that when we take a look at the radio chassis as well. So really, just 4 big screws and removing all the knobs on the front and bringing that little light through that large hole there, and the whole chassis just slides right out. Now, whenever a radio like this is worked on, the electromagnetic speaker has to be sitting beside the radio chassis because the current from the high voltage supply goes through the electromagnet, and the output transformer for the speaker is also on the speaker itself. So there's an audio output transformer and what is called a field coil on the back side of the speaker. So this was before they had permanent magnet speakers. So that has to be in circuit, and that's this cable that you see right here. Gets plugged into the backside of the radio. So I'll remove that as well and get that out of the radio cabinet. And as we're getting closer to completion on this radio receiver, I'll plug that in and we'll see how the original speaker sounds as well. These old radios, they really sound fantastic when they're done properly. It makes AM not sound what you're normally used to hearing. AM is full and rich, and just it sounds absolutely wonderful. So you'll see that when we listen to the radio over here in the end. Here's the radio chassis that we're going to be restoring today. So we'll bring this thing back to life and make it perform the way it did way back in the 30s. And maybe even just a little bit better. So we're going to improve a bunch of things on this chassis, and as I'm going along, I'll explain all of that. So the dial is in very nice condition on this radio receiver. You can see. And you can see the eye tube right in the middle. We'll talk about that in a moment. This lamp that's hanging off the front here was to light that large dial on the front. So the preset channels. To light this dial, they have 6-volt automotive bulbs. Get one of these out of here. You can see that. Big 6-volt auto bulbs. Easy to replace. Let's go down to your local auto supplier and get a 6-volt automotive bulb. So That lights the dial nice and bright. So they were thinking when they put these in, you know, these draw quite a bit of current, and of course they create a lot of light, and it shines in the edge of the glass and it lights the dial up really nice. So a really nice feature. Again, this is probably one of the nicest looking radio dials, in my opinion, that I've seen. They look so nice when they're glowing, and of course with the green eye in the middle and everything, just a fantastic looking radio receiver. So you can see on the bottom side here, they've used a combination of both plastic and cloth wiring. So there's cloth wiring here to the lamps, and then they've got this plastic kind of, it could have been a vinyl wire, whatever. It's just, I guess you could say, crystallized at this point. And what somebody's done is they've put silicone on this to stop it from shorting. As you can see, the whole light assembly turns when you tune the dial here. You can see I'll tune the dial, see that? And as you can see, the wiring is turning with that. And there's a good chance that maybe at some point it was shorting because somebody had put some tape here to stop this from touching this. So of course all of this has to go. So there's a lot of rewiring on this chassis. You can see that the chassis is really rusty. I'm going to have to fix all of that. Looks like somebody was trying to desolder this, maybe to remove this platform to replace the grommets, which they've, looks like they've put some form of a glue under here and some spacer, so that all has to be cleaned up. It looks almost like somebody tried to desolder this, their iron wasn't hot enough. So what they did is they just kind of gave up and then, you know, put some glue under there and some spacers. 25 cycle transformer, so it's good for 25 or 60 cycles. That's why there's so much core on this. There's a cap on the top. A lot of the time the older radio receivers put a rectifier tube and a socket right on the cap. So this is just capped off because they're down here. DeForest Crosley, they did something interesting is, if you're familiar with vacuum tubes, be very careful with this here. You can see that they've only got one plate and filament structure in here. So if you look at a 5U4, 5Y4, 5R4, they have two structures inside. So this is essentially a half-wave rectifier. It's a 2X3. So why they separated the two halves and had one in each tube, I don't know. Maybe to up the tube count on the chassis. I really don't know why they did that, or it's just something that this company did. This chassis here has Rogers spray shield tubes in them. So this is a normal metal tube that you've most likely seen before, and what Rogers did way back when is they used a metallized spray-on coating. So this is a conductive coating they've put on the tube, and they've made essentially glass tubes into metal tubes by doing this with just a little bit of glass exposed on the top. So these are known as spray shield tubes, and you know, it's really common with these chassis. So hopefully they're okay. Usually they're pretty good. You know, I find that these spray shield tubes, they last the term. The 6X6 tube, which is this one here, this is the I tube right in the middle. So I'll just remove this here, move this out of the way. So all of these tubes are now toast. So this is a shoulder type tube. This is a shoulder here, known as ST style tube. The shoulder sits on this, I guess you could say, little metal escutcheon on the bottom side here. And this pokes up through, and you can see the little eye here. Now, these tubes here are very, very hard to find. And if you do find them, a lot of the times they are actually bad because they're used. So I'm going to replace this tube with a more common tube that's easier to get that will do exactly the same thing as this tube, because I want this to look just the way it looked back in the 30s. So this has two shadow angles that move on it, depending on which way you rotate the tube. Say they're on the sides, they'll close and open on the same on the same axis here. So there'll be two of them that do this. Or if you turn the tube, you can have it up and down or whatever way you rotate the tube, right? What we're going to do is design a circuit in this radio chassis so that we can use a standard tube, which I'll show you here in a little bit, a very common tube, to replace the 6X6. One way to tell that these 6X6s are bad, I'll just pull this out of the socket. I'm just pulling this out right now. So it's in here very tight. This could even be the original one. It most likely is Rogers tube. So let's shine a bit of light on here. So if you look at the target inside here, you can see that it's very dark. And I know I have another one over here. This is a good eye tube. Look at the difference in the color of the target. All right, so you can tell the target is really dark and burnt. So this would be a very, very dim tube. So that has to be replaced. Now I'm not going to replace it with this because this only has one shadow angle, but when we get to that point, I'll explain that. And they very nicely capped off one tube socket hole here, which can be used as the driver for that eye tube, which is going to be very nice. So that worked out very well. So I can just leave this out and leave that hanging here. I'm going to just cut this off at any rate and rewire all. This is all cloth wiring. As you can see, it's all breaking. So all of this cloth wire is brittle and snapping. So lots of stuff to do on the top side here. You can take a look at the gearing, and then I'll turn this upside down. There's some gearing on the front, changes bands, and it's to do with that selector in the front. Cams that move all over the place. You see this here, and see this one over here. So if I can get I don't know if I can get enough of a grip on this. I might have to move this like this. There we go. You can see it's moving different things, and this is the switch down here. This is the switch that makes contact to light the different little arrows on the dial. So as you're moving this dial around, as you're selecting frequencies, these little arrows light up, and if you keep an eye on that arrow, I'll rotate the dial. See that little arrow? The whole thing moves around. Really, really neat looking dial. So yeah, just lots of stuff to do. What I'll do is I'll get this thing turned upside down here and steadied on the bench. I got to be very careful with this dial glass. And we'll take a look at the bottom side and see what's done on the underside of this chassis. I've removed the screws from the bottom pan. So there's 2 screws here, 2 here, 1 here, and 1 here, and then the bottom pan just comes off. You can see throughout time somebody has glued a stir stick, or, you know, it looks like a stir stick. They've cut it here and put the other half here, to the bottom portion of the pan here, most likely to space this away from the wooden platform that this sits on inside the radio. Reason that they've done that is because there were rubber bushings that fit into the bottom portion of the radio. You can see the stain right here on each corner, and that spaces this away from that platform for venting reasons and for alignment reasons. So when I say alignment reasons, this thing sits on that wooden platform, and you push this up to the front of the radio so that the dial glass sits into that, you know, the little cutout that they have. And there are a bunch of shafts that poke out of the front of the radio for the controls, and they go through some holes that have been drilled in the front of the radio. So what happens over time is these rubber bushings decay and the chassis collapses, and then what happens is those shafts that stick out of the front of the radio end up collapsing onto the radio itself, onto the wooden chassis, so you get binding. So I guess somebody has found that this stir stick is roughly the same thickness as the rubber grommets that were in there, and this maybe allows it to be aligned somewhat close to the way it used to be. The only problem with this is that you don't get any adjustment. You know, it just sits on this. So the original rubber grommets were, you know, they're a firm rubber grommet, but they allowed you to tighten the screws in differently on the chassis so you could tilt it and align it forward and backwards to get everything just perfect. This wouldn't allow that. It would just sit on this, and, you know, you just tighten the thing down, and away you go. And of course, if you over tighten it, you'd actually pull down on the chassis or, you know, cause issues. So this has to go. These have to be removed. They've been glued on here, and yeah, that should be fun to get that off. So anyways, this has to be pried off, and they're on there really solid. So one thing that has to be repaired, you can see this has been partially repaired. You can see there's some glue that's run down onto the bottom metal pan here, and this sits on like this. So if we look here, somebody has put some glue. I'm just going to move this behind me here. Move that metal pan out of the way. So somebody has put some glue here on the decaying rubber grommets that hold the tuning assembly in, and they haven't waited for the glue to dry, and it's run down the chassis. Thankfully, these are far away from the coils because this even dripped into the bottom of the pan, as you saw. Now, this brings this restoration to a whole other level. Reason being is because all of this has to be scraped off. Normally, if the rubber grommets go away, you can remove the screws, pop some vinyl or rubber grommets in there, and then tighten the screws back down again, and, you know, you're almost done with it. Now this glue is all over the chassis. It has to be removed, and it's also oozed onto the other side, so there's no way I'm going to be able to properly fit the rubber grommets in here. Somebody has put some foam spacers under there, and they've put glue around this, so that all has to be removed. So that might even require the entire removal of the oscillator assembly and everything. So this is going to be a pretty extreme restoration. So I will bring you all along with me through this restoration, and we'll get this thing back up to its old self again. Make it work like a brand new radio. Somebody's used some no-name capacitors and they've left the full lead length on the capacitors in the chassis, which isn't a good idea. Lead length is not your friend when you're dealing with RF, IF, and oscillator circuits. So RF being radio frequency, IF being intermediate frequency, and the oscillator circuits. The lead length needs to be as short as possible between stages, and it's just bad design practice anywhere to have this excessive lead length. Look, there's no dress on it or anything like that. It's just kind of flopping around in here. Look at the length of these leads, right? Just hanging in there. So that all needs to be corrected. The band end of the capacitor, the outside foil end, has not been taken note of on any of these capacitors, so I'm going to have to do my research and put the new capacitors in the correct way. I've designed a device that allows me to locate the outside foil end of these capacitors, and I'll show you how that works here in just a little bit. Look at this, this lead's broken right off, just tacked into place. So that all needs to get fixed. So I don't know what brand name these capacitors are, so they're all going to go because I don't know if they're dependable. So I've spent a lot of time verifying and testing components, and I've made lists about verified and tested components, both for these caps and the electrolytics as well. And I have those lists up on Patreon as attachments. They're in PDF. You just click on the attachment and it'll allow you to download those verified parts lists. So I have a couple of them up there. So if you're interested in restoring radios, test equipment, newer and older equipment, those lists may be of benefit to you. So I am very picky with what I do, and I spend a lot of time verifying these things. So anyways, they're up there. I see a bunch of no-name electrolytic capacitors in here. These will all get taken out, and I will put brand name, verified, real, not fake capacitors in here. Just so you know, if you don't know about this, there's a lot of fake electrolytic capacitors floating around on the market right now. They'll bear the same name as a brand name, and one is real and one is fake. They look identical to each other, except, again, one is not a real capacitor, not the real company at any rate. So whenever you're buying electrolytic capacitors, you want to make sure that you're buying them from a very reputable source, because that source will do the homework and make sure that they're buying the proper capacitors. So I do have examples of fake and real capacitors, and they look identical to each other. Even the stamp on the top and everything, they've done a really good job copying those caps. The only difference is one is very good quality and one is very poor quality. So again, you want to be very careful when you're buying these. These are 85-degree caps, and they've got some funny name on it, so they're all going. Lots of things to be repaired and restored in this chassis. These are bias cells. So these are little batteries that they put in here way back in the 30s to act as bias cells. So these have to get replaced with little button cells now. I'll show you how I do that. There's one here and one here. Somebody's replaced a bunch of resistors with some metal film resistors, and they're just kind of hanging here. Look at this, just kind of no support. Look at this, no support. Right? I could touch the chassis, cause big issues. All of this stuff has to get fixed. Lots of crusty wires. Look at this. This wiring is all bad. It's all breaking and falling off. Look at that. So all of this rubber and sometimes vinyl wiring has to get replaced. So there's lots of it in here. There's a mixture of both cloth type wiring and vinyl wiring. So some of the cloth can stay because it's still okay. Others is, it's just going to have to all get replaced. Somebody has fitted this with a new line cord. This was originally fitted with a cloth cord. I'm going to put a reproduction cloth cord on this. I talk a little bit in other videos about grounding the chassis. The chassis on this radio is isolated from the AC line. There is no connection to the AC line. Now, whenever you install an earth wire onto the chassis, there are, I guess you could say, benefits, and there's also issues that it creates. One of the benefits is, of course, it does earth the chassis. Another problem it does create is that it carries noise from the earth line onto the chassis. And if you have any switch mode power supplies around, say you have computers in your house like everybody has, or anything with a switch mode power supply, phone charger, anything, a lot of the times that earth will carry the noise back to the radio chassis. So people will end up repairing these things, and they use an earthed connection where the chassis, in a case like this, did not have an earth connection. And again, the chassis on this radio receiver is isolated from the AC line. It's not like an All-American 5 or All-American 6 radio. And you plug this thing into the wall and you don't hear anything except switch mode noise. So So there are benefits and downfalls to this. So this is going to get an original reproduction cloth cord put back on this thing, so at least the radio will hear something. This is the speaker out of the cabinet, and again, this needs to be off to the side when I'm powering up the chassis, because the current goes through the field coil here, and of course the audio output transformer is on the speaker as well. So I've been having really good luck with speakers lately. This thing is in fantastic condition. Oh, before I flip this over, you can see here, it looks like a mouse may have chewed through the wire here. All the rest of it is just fine. It's just this one little piece. So what I'll do is I'll end up cutting this, and I'll slip some heat shrink tubing over this or some fibrous tubing, and then resolder the wire and then slide the tubing back over and shrink it on. That should be absolutely fine. The audio transformer is original. The wiring from the transformer goes all the way down here, right into this glued socket. So that's all looking really nice, and the paper on this is absolutely flawless. Look at this. No problems at all. A little bit of glue here, I guess, from when they were gluing the edge. But other than that, the movement is fine. There's no binding. It's in really good condition. I get a lot of questions about this. You know, so many people say, hey, you know, the dust cap is missing. That's the way these speakers were made way back when. They didn't have dust caps on them. So they figured that the grill cloth in the front of the radio was enough. And the speaker still moves just fine, so they were right. So on the back side here is the field coil. It's under this cap. Normally field coils aren't shielded like this, but it's nicely contained under this cap. So hopefully the field coil is okay. I imagine it probably is. If not, getting this cap off looks to be a little bit of an issue because this runs through here and they've crimped a bunch of this cap into the other side here. I'll see if I can show you where they've crimped it. Yeah, you can see right here, they've crimped it in. So I'd somehow have to lift this up very carefully and try and get that off if there's an issue with the field coil. So hopefully there isn't. So thankfully the speaker looks almost brand new, aside from dust and dirt and things like that. So this should make some pretty nice sounds when that radio is restored. All right, let's start the disassembly procedure. So I'll start taking some of the tubes out here. Just slip that under the tube base. Chassis is on a bit of an angle here, so it's hard for me just to pull these straight out. I want to be careful. You don't want to break the index off. So you want to be taking these out as carefully as possible. So there's two tubes right there. Take this one out. It's easy to get out. Remove the cap off of this tube. Move this out of the way. This one out of the way. And so on. As you can see, I'm gently rocking this back and forth. Not enough to break the index off the bottom, but rocking it back and forth just to pull it out of the socket as easy as possible. There's that. So all the tubes are out. That's pretty easy. Now that all the vacuum tubes are out of the way, I'm not going to be using this line cord, so let's just get rid of it. Here it is. And let's see, we'll get this out of the way. So what I want to do is I want to put this little screw back in the clamp. I might have to make an extension for this, so I might TIG weld a little extension to this so I can get this closer for the eye when I go about doing the modification for the eye tube. So I'll bring you through that process as well. So I'm going to have to rewire this, so I'll just gently remove this. There we go, gets that out of the way. Okay, it's already starting to look better. I wonder if these are going to be loose enough to remove by the... A lot of the times if you twist these, a little nut on the bottom comes loose. Oh, this one here is anyways. That still seems pretty tight, so I'll probably have to get in there. Now, of course, all the capacitors and everything in this whole chassis has been discharged. This thing hasn't been powered up in a very, very long time, so everything is very safe. Okay, so I'll leave these for later. I'm going to have to tip the chassis back upside down and hold that with a plier and then twist these here because it's being a little bit frustrating. A lot of the times you can just twist these and they just come right loose because that nut on the bottom is not very tight. As you can see, this one isn't very tight, but it's binding on the threads a little bit. So I don't know if somebody's cross-threaded that on. Who knows with this thing, right? Okay, next up on the removal is these lamps. Let's undo these screws here. Nice big 6-volt automotive lamps. That dial should look just fantastic when that's lit up. Over here, like so. And these are out of the way, and then the next thing I want to do, because I'm going to remove this whole platform, is I'm just going to gently remove all of these wires right here. Just cut right through all of them. So that'll allow me to remove this platform. The next thing I need to do is move the chassis around and start desoldering all of these wires on the controls, because I need to remove this entire platform off the top side of this chassis. So what I'll do is I'll move the chassis around, get an iron warm, and we'll do that. You know what might actually be easier right now is just remove these 2 screws off the front, and then I'll desolder this when I can get the chassis in a more optimum position, because this is really hard to do under this camera with an iron. So I'll just remove these 2 screws that hold this bracket on right here. If I could get that in that screw there. And that's much easier than desoldering right now. So you can see that there's different length of wire here. If you're going to desolder the wires off of anything like this, it's always good to mark that. So you can put a little 1 black dot here and 1 black dot on the wire with a felt, and then maybe 2 black dots here and 2 black dots here on the wire. And then of course the other one would be self-explanatory. That way when you want to put this back on, you know exactly where the wires go. This one goes to the wiper, and then this one goes to the end of the track, right? So that's out of the way. This is kind of wrapped around that, but I imagine that, well, I'll probably have to cut that off too. Let's see. What else have we got here? Lots of gearing to undo. So I imagine I'm going to have to undo this and take this off. So let's see if I can get everything into the shot here. Can I? I might have to use this roll of solder to space this up so that you can see it. And that's right under this, of course. So there's 2 set screws in the shaft here. So what I'll do is I'll slide this. Hopefully this is that. That is the... I've marked this as well already, so I've put a little line on here. So if you're ever going to remove something from a gear, it's always a good idea to put a line so you can get an idea of where you were. And then in the end, if you need to just slightly adjust it, at least you're very close. Okay, so there's that. So I'll just remove all of this. Look at that, how nice that is. Comes right off of there. So that's out of the way. And there's another control here that'll need to come off. You can see this one right here. Another bracket right here. So I'll desolder this later on as well. So I might have to get another roll of solder so that you can see this. Prop this all up. There we go. And hold on to this and pop that loose. That gets that out of the way. So it's kind of wrapped behind everything here. I'll just leave that like so. Look at these wires. I mean, this broken, and it's fixed down here, but left completely cracked up here. These wires are just crispy critters. Look at that. So all this stuff has to go in order to make this thing dependable and safe. I really like the metal dial string. This is an actual metal rope style dial string here. That's really nice. Here's another wire that needs to get removed. This one runs underneath the chassis here, so that is definitely going to be in the way. So we'll see how well this is soldered on here. Sometimes they're not too bad. It's on there pretty good. Keep moving that so it doesn't take hold. Just clip that off there, and I probably can pull that out. Just about. There it is. So the next thing I need to do now is desolder this here. So what I'll do is I will use my very large soldering iron. See see if I can, hopefully you can see all of this. So a lot of the times you need to add solder to this to actually make this desolder, because you need to up the thermal conductivity. So what I'll do is I'll just pull off some of this and I'll heat this up. Now you're not going to be able to desolder something like this with a normal soldering iron because this is soldered to a chassis. So I'll just let that sit on there for a second. Get this under here. And of course I will clean all of this up later on. There it is. Okay, so that's off the chassis there. So I can remove that, and I'm sure there's more of this on the underside. So it's getting close to being able to remove this entire assembly. I may be able to actually leave that shaft on because it looks like the selector switch that's in here is part of this actual platform. And if we look at the front, there's kind of a notch in here. See how they've kind of notched this out? Let's see if I can get this a little bit better into view. See how they've notched that out? Right here. So I might be able to actually leave this on. I'm going to have to desolder this as well. I can see they've got another ground here. And just undo those screws, and then I imagine there might be a wire or two that's running through. I can see this one here. I think that one goes to that selector switch though, that little wire there. And that might just remove that entire platform. So it'd be nice if I don't have to undo that. Alright, kind of hard to do on camera, but there is one lug I had to unsolder under here, and there was another lug that I had to desolder down here. And I undid these 4 screws, and the whole platform basically just came off like this. So that was kind of nice. So I'll get this out of the way. We'll take a look at the platform, and then we'll take a look at the top of the chassis and what other things I need to remove. With the tuning assembly removed, there's just these things that are slid under here, I guess, to space it away. So they are here in some shape or form. Some of them fell out, so I just put them back on top here. You can see the glue has come through the holes, so that's going to all need to be taken off. I'll have to scrape all this glue off, and you can see it's holding this, what's left of the spacers into the holes here. Probably press that through just about. There you go. It's kind of pushing back in there. So, boy, the alignment points are sure a lot easier to get at like this. It's too bad it wasn't like this with the platform on there. So lots of alignment points there. So that's what the top side of the chassis looks like without the tuning assembly on it. So it was relatively easy to get off. It looks complex, but, you know, just some desoldering in areas that you wouldn't suspect, you know, one here, and then some wires that were holding the tuning assembly. I'll show you the tuning assembly here on the bottom side, and just removal of some screws, and away it came. So yeah, lots of things that were desoldered and everything, but not as bad as I figured it was going to be. I thought I'd have to, you know, remove this off of here as well. We'll take a look at that here in just a moment. Here's the tuning assembly removed from the chassis, and as you can see, that switch is part of the bottom platform here. Now it's really hard to see because all those coils were right on top of this here. So now that I have this off, look at this stuck here. So now that I have this all off, I can clean this up and also get the rewiring done on here as well, because all of this, you know, crusty wiring is going to have to be replaced. So I'll put a bunch of wires on here and basically just have a harness maybe sticking off to about here and get that all redone. Try and get the colors as close to the way it was as possible, and then that way I can just match them up to what was there. So this will get brand new wiring up there, and any type of cloth wiring that can remain that is still good, I'd like to leave. But any of the stuff that's cracked and that needs to be replaced will definitely go. So lots of work to do here. So I come back down to my workbench and this is on here. And this obviously means that this doesn't work. So I know my other half has been having problems with her flat iron for a little while. She had to shake it and the thing would come back to life. So let's open this thing up and find out what's going on. If this is how it opens up. Now, I'm not totally unfamiliar with this thing because, okay, with the gates my big transmitter, whenever I would transmit on the gates, this iron would go crazy. There it is. So what would end up happening is the elements would turn on. This goes years and years and years ago now, though. The elements would turn on. So I opened this thing up, and I put some RF, basically blocking, I guess you could say, in there. A little bit of decoupling inside this thing. Let's see, get the proper screwdriver for that. So, but it's been years. Give me a second here. So let's open this thing up and see what goes on here. I think this is the way it worked. I'm hoping this is the way it worked. Aha, it's starting to unfold. So let's remove this. And this. You may hear some planes in here. If you do, just ignore them. I'm telling you, every time I hit the record button, about 50 planes come flying over. I think this is everybody's issue, though. Anybody that does any type of filming at any rate. Okay. That's looking still pretty normal. Alright, so what do we want to do now? We want to get this thing off. All the control circuitry was in here, right? Right. The other side is just an element, I'm sure. Only 2 leads going up in there? Yep. So that would mean that the sensing portion is in this. So, okay, so what's going on in here? You see some of the RF blocking I've added in here years ago. And that looks like to be the issue right there. Actually, look at that. Can you see that? I'll just zoom on in. Oh, man. Anyways, this looks to be the issue right here. So that's broken right off there. So I think that is going to fix this. These are Teflon wires. Alright, I just popped the last cap back in here, and I put a little bit of silicone lubricant on here, and I also tensioned up the little contacts where this rides on in here. As you can see, this can go around in circles so that the cord doesn't twist up, and as we can see, that really works well, right? So what I'm going to do here is turn the temperature rate down to almost nothing here, and I want to see if it cycles, and if it cycles, we're good. So here we go. I think this needs to go into the isolation transformer. Okay, here we go. Oh, there is light. Alright, and the temperature's down to its lowest it'll go, so this should cycle if this is going to work properly. Why is a lot of light here? Let's see what happens. There we go. If I turn this up, it should stay on a little longer. And there it is. Okay. Now this can be turned the other way, I guess, with a... I don't know. What do I have here? I guess I'll have to use this. There. Now she'll be happy, and I can get back to work on this radio again. Now that the important stuff is out of the way, hair crisis averted, let's remove some capacitors. So these are clipped out of circuit, and they're just held in here by some screws. You can see they're kind of loose. So this one here should just unthread. A lot of the times you can just hold the nut on the bottom like I'm doing and unthread it. It's getting a little tight. Hopefully that'll keep coming off. It will. Alright. So there we go. That doesn't sound like a very healthy capacitor. So these here are just dummy caps. They just sit in the chassis to make it look somewhat realistic. That's all. Era specific, I guess. I usually hold on to these things. A lot of people like to restuff these things and put capacitors inside here. And that's fine if you want to do that. But then you got to cut this whole thing open and clean it out. And if you ever want to repair the radio again, you got to open the thing back up again and change the parts and put it all back together. So what I like to do is just use these as dummy caps. Just leave them on the chassis, trim the lead short just so they plug the holes and they makes it look realistic. And put the new caps on the underside. Not like this, but something like this. And that way it's very easy to service in the future, and you don't have to go prying apart filter cans. That one came off really easy, right? So I'll just trim the leads off and put that in there. So there it is. And most likely they've probably been replaced throughout time anyways. I doubt they're the originals. So that is done. Now, the IF transformers have got really bad wiring on them, and they're going to need to be removed as well. So I'm going to take the IF transformers out and put new wire in them, and then clean them up and put them back in here as well. And since we're just about down to a bare top chassis, why not remove the power transformer as well and clean it up? The power transformer is just about completely unhooked. I've marked the wires to some of the pins that they attach to on the tube socket. So 4 dots is pin number 4, and 8 dots would be too many, so I just put a small little 8 right there. And if I lose track, I'm really not too worried. I'll just ohm it out and reconnect it anyways. So, yeah. One of the things that's kind of aggravating about this manufacturer is that once they solder to these little tabs here, these ground tabs to the chassis, they bend them down and they crimp the actual wire into the opening. So you can see it's a little punched opening under here. I don't know if you can see that. So this is just a punch in the chassis. That's not a shadow, that's an actual opening. And then they solder to them, or they wrap the wires and they push them down. Most manufacturers don't do that. You just wrap the wires and then you put some solder on here, and then the next time you want to get the thing apart, you just desolder it and pull the wires off without crimping it hard towards the chassis. Like, look at this. See, they've soldered to this. So they put the wires through, pushed it down, and then soldered it. So a little bit excessive. And that makes removing the wires, example, this one right here, very difficult. So I'm going to have to rewire the dial lamps. This wire is all like very crispy. So what I'll do is I'll just very gently remove this like so, and that gets that out of the way. So I'll just leave these wires here. There's a black one and 2 green ones here. And then this is the filament string that gives filament to the entire radio. So this here, it looks like at some point maybe it shorted out and somebody joined it to another wire here. This is a different wire, and then to this here. And then this one runs all the way down here. I really don't know. So what I'm going to do is I'll clip this one here, and then that way I know this wire goes to this side. And it's probably not really all that important which wire goes to which side. But yeah, I think what I might actually do is I'll just desolder this and mark this. And then that way I'm not going to be left with short lead length, because this is looking like it's getting pretty tight. And if I cut that, I'm going to be pulling that tight. So what I'll do is I'll desolder this and we'll take the transformer out. All right, well, I went and desoldered this side here, and they've wrapped the lead so much around this post here that I'm going to have to take everything off. So I just pulled it and cut this, and I cut this one here because this is going to have to get replaced anyways. So this is, I'm not going to leave this like this, right? So enough of a marking at any rate for me to put that back in there. So now what we need to do is get rid of the mounting on the bottom here. I've straightened all of these up. They're still pretty flexible, not really too crispy. Not like the other wiring in here, that's for sure. So, of course I'm going to be picking all the hardware out of this thing. Just needs a good shake. So let's see, get this out of the way. There we go. Move this stuff out of the way. Boy, that chassis sure is light without this thing on there. Look at that big tar-filled transformer. So, it looks like it's in good condition still. This is very standard for these old transformers. They fill them full of tar on the bottom side here. And it's looking like it's okay. So, what I'll most likely do before I go about putting this whole thing back together with this transformer is testing it out, making sure that I don't reassemble the entire radio with a bad transformer. I really doubt it's bad. I'm about to remove the IF transformers from the top. And one thing to note in some of these older radio receivers, they have a neutralizing connection in order to stop this thing from breaking into oscillation when you really peak the IF up. So when you get lots of sensitivity out of the IF section, sometimes when you have tubes with caps on the tops of them, they get a little bit excited and want to break into oscillation. So they have a lead that comes out of this IF transformer and wraps around the yellow lead of the other IF transformer. It's kind of hard to see in there. I'm going to try and hold this up in midair and point to it at the same time. So you see this? Lead is just wrapped around this yellow wire. So let's see if I can hold this up and get some better light on it. There we go. Pardon the lamp and the shot there. So if you look in there, it's just wrapped around. So it comes out of this transformer here, runs over through here, and then it wraps basically one turn around the yellow lead that's coming out of this transformer. That is known, when you wrap a lead around another lead like that, that's known as a gimmick capacitor. And that's what they're using as the neutralizing capacitor. Basically, it's just one turn, so you're looking at a few picofarad or something like that. Just enough to give this a bit of feedback so the thing doesn't break into oscillation. So it's very important to note. So if you're ever working on an older radio receiver and you see a one lead come out of a transformer, it goes nowhere, just makes a loop around another lead, that's usually for neutralization. So what I'm going to do is just cut all the existing wires that go to the IF transformer to put all brand new wires in the IF transformer. And since this has to be wrapped around another lead, I may replace this with a solid. These are going to be replaced with stranded leads, and I'll run a solid lead wire here so that when I wrap it around, it'll stay wrapped around the yellow lead that will be replaced in this other transformer. So what I'll do is, let's see if I can do this all here on camera. So I'll just trim this off. I don't want to put any stress on that transformer down in there. I don't want to put any stress on that at all. So there's enough color left here that I can just follow the colors back. And again, not a big deal. I'll just trace the circuitry if anything else happens. So that's that. That looks to be about 5/16. Do I have 5/16? Let's see here. I do. That out of the way. And can I get this down in here? Doesn't look like it is going to get very close to the wall there. May have to tilt this just a bit. Probably replace that with a 1/4 inch, not 5/16, and then that way I can get the nut driver down in there. And there's the IF transformer with the neutralizing lead here. I'll just get the focus on this where it should be. So there's the neutralizing lead right there. And then we have what looks to be black, yellow, and red. So I'll replace those with the appropriate colors, leave myself some lead length, and then I can adjust that accordingly. And while this is out, I'll remove the IF transformer. I'll show you what's inside this as well in just a moment, clear some of this stuff out of the way, and we'll check that out. I'll show you what's inside these things. Okay, so here's one of the transformers. Let's open this one up. This one has a lead on the top, so I'll have to trim this off. So they're pretty much the same. It's just this one here doesn't have a lead that runs off to the grid cap. That's all. So I'll open this one up and give this a bit of a press. So usually they come out fairly easy. This one here looks like it's trying to fight just a little bit. There it is. I put this around here to stop any wires from shorting to the case. And this is going to be extremely brittle. You can see this. Looks like they actually put a little rubber band in there way back when. So, let's see if I can open this up without destroying this. I doubt it. Probably I'll have to just wrap this with something new. This old paper is just so tender by now. Yeah, it's looking like I'm gonna probably be replacing this. Yeah, it's so brittle. So I'll just open this up and I'll replace this. It's like unwrapping a Christmas present, but not so much. Let's see here. There we go. And that's what's inside one of these IF transformers. You can see variable capacitors on the top and a bunch of coils that look to be in good condition. So it's looking good. I've spent a little bit of time cleaning up the tuning assembly and it turned out okay. So basically a toothbrush, and the product that I use, I'm not endorsed by this company at all, but it works very well. It's a product called Vim, V-I-M. And I just went in here and just scrubbed away with a toothbrush and cleaned it up, and it turned out like this, which isn't too bad. So looks a lot better than it did. So I haven't done anything with the dial glass, I just removed it, and there's a piece of steel that is also painted flat black that sits in here like this. This is perfect, so I don't need to touch this. I have to clean that up a little bit yet, and as you can see, the gearing is all cleaned up. I tightened up this metal dial string. It was just a little bit loose, so now there is no slop. It's very positive, so you just basically move this, just touch this, and this responds right away. So that works very, very well. So I've got quite a bit of assembly here just to get this thing all back together. I've also cleaned this all up. There's a gear. They have a mark on it on the backside here, but there's a gearing assembly in here that works for the presets. This is the presets that sit back over here. So that all has to get reinstalled, and I have to get the timing right. And I resolder the wires that go to that switch here. And this here is pretty much cleaned up and ready to sit back on the chassis. Now I haven't done anything with the wiring yet. I'll do that just before I put this all back on. So I'll remove these lamps. So there's some screws here that I can remove. I don't know if you can see that screw here, and there's another one on here. And depending on how you rotate the dial, like if I rotate the dial here, I can get to all the different screws. And then I'll just take this off as one assembly and then measure everything, map it out. I'm going to have to cut this off here because they've fed the wires through a little clip that's spot welded on. So I'll have to feed the new wires through that clip again. And I'll have all the new wires hanging off here before I put this back onto the chassis. So I'll show you that before that's done. So now I'm onto the chassis. I'm going to start cleaning up the chassis and making it presentable as well. So it's coming along. The next thing to do is to take all the rust off of this chassis. Now, in order to keep the rust off this chassis, I'm going to have to paint this. There's just no way around it. If I use rust remover and clean this all off, it's just going to rust again. So the best thing to do is just to give it a coat of paint, and that way it'll stay looking nice for a very, very long period of time, and no rust will happen again. I noticed in the other radio receiver as well that the chassis is rusty. So I'm thinking that the plating is just very thin on these chassis. So the best solution is to remove the rust. So I'm going to remove the oscillator assembly, so that requires me removing these screws here and these screws here on these two capacitor assemblies. And I have to desolder this copper strap, this one down here. You can see that blob of solder down there. And then there's another one over here. Remove some wires, remove the nut off the shaft here, and remove this little switch, and it should just slide back and out. There's a couple of wires that will need to get removed that run off the assembly as well. Not a whole lot. So get that out of here and just clean the chassis off. I'm going to remove the controls as well. So I'll remove these controls, this is just held on by two wires right now, right here, or a wire, a coax, a piece of coax cable here running out. And the same with this. Right, I'll just remove this and get all of this stuff off the chassis so the chassis is clean. That'll allow me to clean this and paint this very nicely. And then I will start the reassembly procedure. So as I'm going through this and cleaning this up, I will bring all of you along through the experience. So I'll get going on that right now. These chassis soldering blobs are always a lot of fun. So what I'm going to do is I'm just going to hold on to the end of this little copper strap. It runs through, and I will grab my Weller iron with a modified tip. I have a video on this as well here on YouTube. And this makes very easy work of melting this solder. You can see it's already melting. Of course, you know, the chassis to this is a big heat sink. I'm just going to add a little bit of solder actually while I'm waiting. I could actually grab this solder, that would be great. You can see when you add some how much faster that is. These wires are all in the way. Look at that, it's almost turning this into a molten blob of solder already. So I'll move this over here and just work this back, and that's just out there like that. And I'll do that with this one over here as well. So let's heat this one up. And that one is loose. And now I just got to do the two front ones and remove some screws and take this off. I'll just move this out of the way. Take this nut off on the front here, and this whole thing should just lift up and come out. Again, I still have to undo these as well. I'm leaving the capacitors tight to hold everything steady as I'm doing this because I don't want everything to shift. All the coils and everything are fastened to the switch, or to the actual wafer switch here, and to these caps. So if I loosen this off and I'm pulling on these wires, things might shift a little bit, so I want everything to remain solid while I'm removing the solder, and then after all the solder is removed, then I will just back this out and pull this out. I've already got all of the wiring harnesses undone. You know, all the lighting is, I'll just back this out here. All the lighting has been taken off, as you can see here. That's all going to get rewired as well. Everything's wrapping around everything here. This is all removed, and let's see what else is removed. I removed both of the controls off the front here. Nice thing about this is the wiring, the cloth wiring, is still very flexible. That runs into this switch, and it's a good thing it is. Here, let's get the focus on this. And it's a good thing it is because they've riveted this little cover over the connections here. So it's nice that this wire is still nice and soft. This is probably the softest cloth wire in this entire radio, so that's very nice. Nothing is broken here, so that'll keep a little bit of the original look happening on the outside. Again, this is a mixture of vinyl and cloth wiring in this radio, so mixing, you know, rubber or vinyl wire again with cloth wiring, it should blend in quite nicely. I've removed this control as well, so there's, you know, the chassis, you know, getting pretty stripped down. I've got this loose. So a little antenna transformer. All right, this is about the most difficult solder blob to get at down here because it's so close to this coil here, and luckily this is thin enough. You can see I've bent the tip already and I've touched it down there. I've added a bit of solder to make this just a little bit easier to do on camera. So I've got these little tools here that lock, and this will hold on to that little copper strip down at the bottom. So what I'm going to do is bring this forward, put this onto here like so. See that right there? Got it on the copper strip. Give it one click and that'll hold that. And thankfully there's quite a bit of room here, so I can lift this into this area right here. So I'm going to attempt to put this down in here like so. Just like that. I don't know if you're going to be able to see that. Let's see if I can get that in there. Be very careful around that coil, as you can see. And I will try to lift this up to put just a little bit of up pressure on this. It's really hard to see because it's such a tight area. There it is. Let off just like that. So it's out of the solder blob. We'll very carefully open these, and there it is. Nice and free, ready to get resoldered. So what I'm going to do is I'm just going to clean all this off as well. Once this is all removed, I'll clean off all this soldered area, and then I'll add new solder and a little bit of flux to that, and it should work quite nice. So it's just about ready to come out. Let's see what else. What can we do here? So what I'll do is I'll remove these right here and get that freed up. Okay, that there. Lots of disassembly too. bring this thing back. As you can see, this is going to just be hanging in here by the coils. That's the reason I left everything tight while this was happening. So you're probably asking yourself, boy, you're sure going through a lot of work to make this radio come back to life. Yes, it is a really neat radio, and it would be nice to preserve history. So if I put a coating on the chassis here, you know, this is going to stop it from rusting, and it'll be around another 80 years. And people can experience this. They can go, wow, that's what this was like way back when. And it was restored way back in 2021. Hey, do you remember all that weird stuff happening in 2021? So, back then, you know, it'll probably be the history book saying that. Okay, let's see. There it is. Entire coil assembly is removed. So what I can do now is I can clean this up as well. Get this all nice and clean. And I'll just put this off to the side. Be very careful with it. And I'm just about ready to start masking things off here on the top side and get it ready to clean up. Still got to scrape all this stuff off. So that should be fun to get off. This here was really nice. This just kind of fell off. This one did, and this one almost fell off. A little bit of pulling, so maybe a bit of tugging or maybe some heat to the chassis and the surrounding area. Maybe this will just come off. And that'll make that really nice. So now that that's done, I can probably do this as well. So this is going to get rewired. So why not just take it off right here? Like so. And there's a little coil in there. Doesn't look like it's been hot, which is kind of nice. And there's a nice big mica capacitor in there. The chassis has been cleaned up, as you can see. So this has been glass bead blasted, and this is now ready for paint. So that worked out okay. So that's nice and clean. So I just have to mask off the sockets and some small things here, and I can get this ready for paint. The reason I'm wearing these gloves is I don't want to get the oils from my hand on this because the metal will rust really quickly. So let's move this out of the way. And while I was at it, I also did the power transformer. So that's ready for paint as well. The nice thing about this glass bead blasting is it preps the surface as well. So you can see how it kind of looks a little bit sparkly here. And that's because it is roughed up. And it takes paint very, very well. So paint will stick to this. It'll be a really, really good surface for paint. So that's that. And here are the IF transformers. Clean those up as well. Another one here. So I might paint these a darker finish. So this was a darker color. Now, I don't know if it was like that or if it was just incredibly dirty. It's kind of, you know, the color it's inside there. So I'll probably paint these a darker color. And of course, I'll paint the transformer darker color. So that should really stand out on the chassis. It'll look really nice. And here's the little antenna transformer cover. So all of this should take paint very nicely. So what I'm going to do is get all of these painted up. And then in the meanwhile, while the paint is setting on this, because it's going to need some setup time, I don't want to be handling this after it's painted right away, I'll start working on the dial. So I'll start putting the new wiring onto the lamps and all that kind of stuff and feeding the wires through, things like that. And I'll show you how that's done in just a moment. Just before I go about removing the shielded grid lead on the top side of the chassis, so the shield is soldered right here, and this is the grid lead, I'd like to show you a pretty substantial mistake that DeForest Crosley has made. And if you design anything with vacuum tubes, you want to take note of this. So this is where the filament current comes from the transformer, and then it runs through this twisted lead. And the reason that they twist this is for the cancellation effect. And this is running from tube socket to tube socket, so it's basically going from here to here to here to here, and then to another tube socket here, and then the eye tube also gets fed off that. So you can see there's no leads twisted here, because it's kind of hard to do that. You can see they've twisted the leads just like one twist here. you know, and it's running from tube socket to tube socket. So this is a filament lead right here. Now, the grid cap on the amplifying triode is extremely sensitive to hum or anything. So basically, if I put my hand even close to that tube, to the tube cap, while the radio's on, it will induce hum. Like you'll hear hum in the speaker. If I put a screwdriver or something just close to that tube with the chassis upside down, again, we'll get hum. So we know that the grid cap of the amplifying triode is extremely sensitive, and that's the reason that they've shielded it on the upper side of the chassis. Okay, so some of the metal tubes, not the spray shield tubes like this, but the metal tubes, they have a little cap that pops on top of the metal tube itself and acts as shielding to keep everything shielded. So for the, you know, the 6K7, we'll say, all right, the 6K7 tube has a cap on the top, whereas the 6SK7, they moved the grid connection to the base of the vacuum tube, and that's how that works with the S series. So the 6Q7, right, would have the cap on the top, where the 6SQ7 has the connection on the bottom, so on and so forth. So now we can see here we have a lead running directly over a filament line. Now keep in mind that there's 4 tubes after this. There's this tube, a tube here, another tube in the front, and the I tube is all pulling current on this filament line here. So there's going to be a substantial field on this wire, and that is going to induce hum into the radio receiver. There's just no way around it. It will make this thing hum. Now, it might not be incredible, but it'll be enough to be noticeable in the speaker all the time. So in order to improve the performance of this radio receiver, I'm going to definitely move this connection here away from this filament lead. Look at that. Like it's right on that AC line. I'll just zoom on in here as close as I can get. It's right. See that there? It's right on the line. Right? Again, substantial current being drawn on this, right? Now the filament lead isn't running in parallel with it, so it's not going to pick up a whole lot. It's just jumping over, but there is still area, and there will be coupling between these. So what I need to do is desolder this blob right here, and then take the shielded wire off the top side here. So you can see this shielded wire on the top that runs up to the grid cap, right? So I'll put a new piece of wire on here and just go from there. As you can see, I've done a lot of masking here already. Just put this down and I'll show you what's going on. Pardon the camera as I'm grabbing the lens there, a little bit of a shake. So I've masked off all the tube sockets, as you can see, and it's pretty much ready for paint, but I want to get this lead out of here before I do that. So I'll end up desoldering this here and fixing that up. I'll leave the lead out until all this is all set, and then I'll work with the chassis later on once the paint is all done. But that is a real substantial mistake. I'm very surprised that just got past quality inspection or whatever. That's ridiculous. Right over a filament lead. So definitely going to be fixed. That will lower the hum at the speaker in this radio substantially. The chassis and the rest of the IF cans transformer and the little antenna transformer cover have all been painted now, and I have to wait for that paint cure for a couple of days. I want the paint to get nice and hard before I go about handling the chassis and everything and putting everything all back together. So there's lots of stuff to do in that couple of days. So what I'll do is I will start removing the light assembly from this dial here, and I'm going to just run a whole bunch of wires out of here, and I'll just leave them probably about this long. So I'll just have the wiring hanging off here, and that way, when I'm ready to install this, everything is just ready to go back in. So, and that'll be the same thing for the I-tube here. I'll rewire the I-tube socket, and I'll also have to make that little extension, and I'll show you that when I do that, to hold the other I-tube really close. It's a much smaller I-tube, so I have to get all of that ready, and I'll have another wiring harness just kind of hanging off as well, and just get this whole thing ready. And then, of course, I'll put the dial lights back in here and have that wiring harness hanging off as well, so this thing is going to look like an octopus when it's done. So what I'll do is I'll get this screw out down here. So I'll grab this screwdriver and pop that in there like so. Give that a bit of a twist. They use a combination of these slot-headed screws and Robertson screws on this. It would have been nice if they just kept everything all the same. The Robertson screw would have been really beneficial in here, because it's very positive and it locks in. So I have to get to this one up here. There's a screw right up in there. See that? I can probably move the dial back just a little bit. There. See that one there? So I'll get this one out of here. Like that. Just loosen it off. Just let it fall on the bench. There it is. And then there's one on the bottom down here as well. So I'll get rid of this one. And I'm hoping that this whole assembly will just come out relatively easy. It looks like it will if I take it out this way here. So now, let's get rid of this. Again, this is spot welded onto the front here. I don't know if you can see that. I'll just zoom on into this here a little bit. You can see this is spot welded onto here, and they've run the wires through this, so I'm going to have to do the same thing. So I'll most likely take this whole thing out and leave this the way it is, or very close to the way it is. Leave all the wiring the same length. Let's see if we can see that here. Leave all the wiring the same length, and then put this down on something. Maybe even tape these onto a piece of paper. Just back this out here. Tape this onto a piece of paper, and then just rewire it so it holds the sockets in place. I really don't want to bend these wires too much because I want to kind of keep its form. So there's that, and it looks like I will. Look at that. So I'll just move this out of the way. I'll recolor these as well. Now, my better sense tells me that I should most likely get a colored LED and put it on the backside here and just have it shine in very close. I could even make something that would almost clip right onto here, and that way it would never get hot. This thing here would never, go away after that, and it would always be a solid color. And on the other half, I really don't want any solid state stuff in this because of the depth of restoration that I'm going to for this. So I think I'll stick with the incandescent bulbs, and I'll just recolor this. This is supposed to be a color, right? And that shines through this little arrow. So it looks, red. I think the same as the other one on the bottom. So there's two red ones. And then the inner one I think is green. I can see it from here. You can see that it's green in there. So that's okay. So maybe I'll just recolor this. It would be so much better to use an LED, but in the same way, it's kind of, I don't know, it just doesn't fit in this situation, I guess. I know there'll be some of you that are saying, yeah, go for the LED, make a little mod, and there'll others that'll go, don't do that, that's horrible. So it really is a personal preference thing. So I think I'm just going to stick with this. So as you can see, this is holding its form, which is very, very nice. So what I'm going to do now is I'll take this, put this on a piece of cardboard, and I'm going to tape this down, probably with some Gorilla Tape or something like that. Just tape these down. And then at that point, this will be solid on the cardboard, and then I can desolder the wires, and everything will stay in its position, and I can rewire this entire thing, and it'll just fit right back in. So I'll get that done, and I'll show you how this is going to look when this is all finished. Look at this. Look at this here. It's all siliconed up. I don't even think that's going to come out that way because there's a little piece of tape on this side. So let's cut this side and poke it through this way here. There it is. Look at these wires. Just falling apart. So yeah, you can see how that's spot welded. So I'm going to have fun fitting all those new wires through there. So I'm using 18 gauge wire for this. So I think it should probably 4 wires should fit through there okay. All right, I'll get this rewired and I'll put that in and I'll show you how that's done. A little bit of felt marker on that, and that looks pretty good. So that should shine nice and red now. I might do that to the other red one as well, just in case it has been faded. The green one looks pretty solid. I have a green felt as well if I need to do that. So that should make that okay. So I'll get this out of the way. And so this is what I've done with the lamps. So what I've done is I've taken some really sticky tape and put this down like so. This is where the wiring harness goes out. And this will allow me to work on this without these moving around. And I can basically size up the wiring, and this will just fit right back on that little moving dial. And I'll leave quite a bit of lead length here because this has to have a little bit of a loop in it because there's a strain relief as this is turning around, right? And then leave some extra that'll run down to that switch. So I'll get that all put together and I'll be back. I have the new wiring installed on the lamps here. So this is nice high temperature wire. And I've used some silicon coated shielding here. It's a fibrous tubing with a silicon coating on the top in the parts where the actual silicone will touch this metal frame, and there's just no way around it. Even at the factory, that's how this worked. So I've experimented with this a long time, moving this clip around to different angles to find the point of least contact throughout the entire travel, and this is it. So what I'll do is I'll show you, for any of you that are rebuilding a DeForest Crosley, you might want to take note of this. So this is at the end of its travel down here. And what I've also done is I've filed all the corners of these metal brackets smooth. Up in this area, up here it's filed smooth, and down in here. And that's very important because from the factory, this was actually really sharp. So this is nice and smooth now. And then, of course, with this pipe and that silicone, that smooth silicone coating, when it touches at the top here, it won't cut through. So what I'll do is there's a point of contact here, right? And where these two silicone pipes touch, there's a point of contact. So this is right at the end here. So there's a little bit of contact here right as the wiring comes to the end. Now what I'll do is I will show you how this works. So I'll turn the dial here. Now as you can see how this is unwinding, it's because there's a twist here and then it comes out of the bracket on this angle. Now this is the best angle to reduce the interference. So there's a bit of interference here, you can see. So as that goes around there, and that's to the end. So that's the end of the dial there. So there's a little bit of touching there, and this is the way it was from the factory. Keep that in mind. So this is just extra protection for the wiring, this fibrous tubing. And that comes around. And as you can see, as this starts to curl up, it puts that bend in here and prepares it to go under this portion of the bracket. See that? And then that just guides it. Right now it's touching this point right here, and that just guides it under nice and smooth. The factory eye tube for this, as talked about earlier, is the 6X6, and of course it's long since bad. So I'm going to replace that with a 6AF6 right here. This is a much more common tube, and it has a dual shadow angle just like this. Basically, the top end of this tube is the top end of this tube right here with just no triode. This triode that is missing in the replacement tube will be fitted on the chassis. So this should work out really nice, and this is replaceable. There's quite a few of these still available. So that makes a nice replacement for a tube that is long since gone. Now, the socket for the 6X6, they put this little cup in here, most likely maybe for marketing reasons or something like that. So you can see the base of the 6X6 will fit down inside here like this, right? Whereas a standard tube won't fit. It just stops it from fitting. So maybe you would buy a replacement 6X6 way back when, and it was a big deal to have that tube, and it wouldn't fit. And they're like, oh, it won't fit in here. Well, this can just be removed. This little piece right here. These tube sockets here, this remote tube socket is a very common piece. So getting this apart isn't too big of a deal. I'll just get this clip off of here. Let's move that off if I can. There it is. Let's get that out of the way. And I'm going to have to make the adapter with this to fit the 6AF6 up in there. And let's see, right about here is where we would pry. You can see there's a little notch. So what I will do is get this screwdriver in here and give this a bit of a twist. And I'll just work my way around like so. And there it is. Just comes apart like this. You can take this all out of here. Nice little shield to stop the wiring from touching the can. I'll keep that because that's in good condition. And as you can see, this thing here will just slip off. And this will just pop back together without that. And in that way, I can use this tube because now this tube will plug into here quite nicely. So this will have to be fitted. Just move all this stuff out of the way. This will have to be fitted up into here. So that will have to sit right up in there. So I'll just hold this here and turn this the other way around. So we have our eye tube in the center. So what I need to do is make this bracket. So this will fit on the cup, right? So just say the tube socket was on here. This cup would be on here like this. And then this clip would be on here. But the difference is this is going to now be sitting way up in here, whereas the mounting is down here. So I'll have to make a little extension that will run up and hold the tube in over here. And that's what I will work on next, along with rewiring this appropriately so that it will work with this tube. And there'll be another wiring, somewhat of an umbilical cord here sticking off that will run down into the chassis. The eye tube socket has been rewired for the 6AF6. So the twisted pair brown lead are the filament wires, and there's only 3 other leads needed to make this work. Both ray control electrodes are tied together, and that is the blue wire. The target is the purple wire, and the cathode is the black wire. So all of these leads will make this eye tube perform just like that original 6x6. I've also TIG welded up the bracket that's going to hold this closer to the dial face, and I've painted that. So the paint is setting right now. So the next thing on the list to do is to start rewiring the IF transformers and get some lead length on those and get those ready to reinstall back in the chassis. So I'll grab one of those and I'll show you exactly how I'm going to do that. I've replaced the black wire in this IF transformer already with this new one right here. So this one here will be the next one that we will do together. Now, depending on your soldering skills, you may feel more comfortable in just trimming the wire off and then soldering a new wire to the inside here. Or if you're more confident with your soldering skills, you can cut the wire off like so and remove the green wire from there. And you can desolder it from here. So usually what they do is they put the wire on the outside and fold it on the inside here because of the close clearance to the shell. So a lot of the times you can just heat this, pull that up like so at first, and then just take the wire out, just that easy. And then if you want, you can vacuum it out if you have a vacuuming tool. So you can vacuum this out. So you want to be careful again because there's a really fine wire there, right? And that runs off to this coil here. So you can see that's in there. So what I'm going to do is push this out of the way so I can put the new wire in here quite comfortably. And then all I will do is feed the new green wire into there, which of course I don't have on the bench. I have every color except the green wire. I just did the black one. So I'll have to go get a green wire and I will put that in here. I'll go grab that and I'll be right back. All right, I got some green wire. I tell you, I have every color on this bench possible. Blue, brown, red, every single color here it seems. Yellow, orange, white, so purple, all sorts of different colors. And then of course green. The wire that I removed to show you is missing. So actually what I'll do here is I'll put this through here like this. And then what I want to do is I want to hold this down while I'm soldering this so I can use this little tab here that this little area here that they've got just to hold it while I'm soldering it, just like that. So that works out really well. Get the insulation off of the plate, the piece that I'm going to solder here. And give that a bit of a press. And that should be good. And then what I'll do, add some solder to this. Like so. There it is. Let that set for 1 second here. There we go. That's solid now. Then what I'll do is I'll cut off a little bit of length. I'll just make all the lead length the same. Very close to here. There's that. And that's done. I often get the question, Paul, why don't you show us how you do this stuff on camera? Why don't you show us how you solder this stuff? So you know what I'll do? I'll take you through the yellow wire soldering. Now I like this red stuff, this 18 gauge much better, because you can see I can move this around, right? And this hardly moves. There's a bit of a relief here so that it doesn't pull the wire out of the IF transformer. You look at this one, see how much that moves around? So using this larger wire is a better solution once it's tinned. It's much more rigid. So that's a definite improvement. Now, mind you, this is only going to get moved until you mount this inside the chassis, and it'll never get moved again. But still, it would be a real pain if you were to install this and say, you know, one of these little wires was to pull off. You can even see I can twist this, whereas there's just absolutely no way I can twist this 18 gauge wire. So yeah, a little bit scary at that point. So I'm looking forward to changing this out with an 18 gauge wire. So what I need to do is take this off of here. So I'll just do this on camera, and hopefully I can keep this all into the shot, because the camera is very, very sensitive to movement at this focal range here. The camera is quite a ways away. So of course it has to be above the desktop. All right, so what I'll do is I'll grab this with my surface mount tweezers, and then what I'm going to do, that's that little wire that comes out of the IF transformer there. And what I'm going to do is just heat this and pull that off carefully. See that? So that is now released. And then what I'm going to do, now that this is off of here, is I'll just move this out of the way like so, so I can get this yellow wire out. I want to leave this on while I'm desoldering it, because I can heat this and very quickly, here's the trick. You heat the top, you very quickly move this up, and then it unwraps this. So if you heat it too much, then the whole thing will want to move. So if you just get the top hot, this will pull up, and I'll show you what I mean here, and it just makes removal easy. So you heat this up just like so, like that. See that? Now I can twist this, and it just comes right out. See how easy that is? So all about timing, and of course doing this about a million times. Okay, so that is now cleaned off, and I have a piece of yellow wire already ready to go here. So what I'll do is just put this in here like this, and then what I want to do is use this to hold it, which is really nice. Makes things a lot easier. So bend that straight. Just like that. And then what I'm going to do is I'm just going to tin this whole thing. So I'm going to get this little wire out of the way, and I'll attach that later. So I'll just tin this whole thing. So I'll add a little bit of flux to the wire, and that way it'll tin really easily. Just like that. I'll be able to just run the wire along here, so give it just a bit of solder, and once it takes, I'll just be able to move right along. Like so. All right. Let that sit for just a moment. I can see it slowly hardening up there. So now I've got this wire, and I don't want to pull this tight because I want to leave a strain relief here, right? You can see there's quite a bit of wire there, and they do that because there is movement when you're installing this, right? So it doesn't take much to fasten this to this. All you want to do is really just put a loop around here. Just like that. And I just want it to go around the other side so that it doesn't try and unravel while I'm soldering it. So I can see this little android here. Amazing I'm actually not doing this on camera. Hopefully this is looking okay. I'll look up to the camera in just a moment. Okay, so that'll hold that. All right, it is in focus. That's good. All right. So What I'll do is I'll just touch this to here like so. That's it. It's redone. Now you can see there's a strain relief here, so there's actually quite a bit of wire here. See that? All that wire that's running into the IF transformer. So if this moves around, as you can see, which it hardly does now. See how much more rigid it is with this better wire? So you can see that, right? So that'll last a term, and I can be, well, I can be gentle with it, but you know, when you're pulling wires through chassis and things like that, that's what you end up with. So you end up with breaking things off if things aren't tough. So there it is. There's all the brand new wires on the bottom portion of this IF transformer. And now I just have to do the other one. The other one has actually another lead on the bottom here, which is that neutralizing lead, and then it has a grid cap lead on it. So there's lots of leads on the other one. So I'll get that all done and on to the next portion of this restoration. Another step that you may want to do is just make sure that both of the coils are good before you put this whole thing back together. So the bottom coil goes from the red to the yellow lead here. So what I'll do is I'll just put my probe leads on here. Make sure that I have continuity, no problems. So that's the bottom one. And then the upper one goes from the green to the black lead. So I'll just put this on here like so and like so. And no problems there either. So both of the coils in the IF transformer are okay. You probably would want to test this after you rewire it or do something as invasive as this, because if for some reason you've tugged on something and one of the leads is, say, loose or it's not connected, and you put the entire radio back together and you wire this all in and all the wiring is tucked in the chassis, and you find out that one of these coils is open, that would probably give you a pretty bad day. I'm just about ready to start putting all of this back together. This is what the chassis looks like after it has been painted and cleaned up. What a difference. And I'll show you one other component here. This is the power transformer. So there you have it. I like the finish. That worked out very well. So this will all get mounted back together. And this radio should look pretty close to new, if not a little bit better, very, very soon. So I got to get the rubber grommets or vinyl grommets into the chassis here and put the oscillator assembly back in and the IF transformers back on and all that stuff. And once I have everything mounted here, even before I start wiring it again, I'll show you exactly what's going on. This is the Dialite assembly for the radio right here. So these here attach to the dial face and they light up the glass dial. So this all needs to get cleaned up. I'll clean all of this up as well. And as you can see, the wiring is all breaking. Look at how brittle this is, right? You can just break it just by doing that. So all that all needs to get replaced. It's very easy to get out of here. So just heat that little button in the middle. It's soldered in there, and you pull the wire out and put a new wire in and resolder it. And then, of course, the other wire is attached to this tab right here. Now, keep in mind that this has a center-tapped filament transformer. So this barrel is not connected to the chassis. It's isolated from the chassis. So if this touches the chassis like that, you'll short the power transformer. So something to keep in mind. So always make sure that there's a bit of a space between this and this bracket right here, just like so. You definitely don't want these to touch, or magic smoke will come out of the power transformer. Now, what they've done is, I don't know, it's just kind of ugly. They have these attached to the dial face, and then they have a wire that runs around the front of the dial, and another wire that runs around the front of the dial, and it runs to this thing, which pokes through the wooden case of the radio and sits on the front, and this lights up the presets. Now, Kapton tape is the exact same color as this little film that's broken off, so I'll just put some of that over there and it'll give it a nice orange glow. So surprisingly similar Kapton tape to this stuff. So I'll fix that up, and what I'm going to do is I'm going to run a separate wire assembly for this. I'm not going to have this attached to here because it looks horrible having these wires that go around the front. So we'll have these as a twisted pair running down to the same point where this switch is, and then running into the chassis, and then I'll have a separate twisted pair running out to this lamp. That also makes servicing easier as well, because I can have a little bit of access lead length, and I can move the chassis to the side and push this through easier and, put the chassis back in. So it's a big benefit to do that. And it just makes things look all that much nicer as well. So lots of rewiring to do there. And then, of course, once this is done, this will just screw to the dial face. And I don't have this thing hanging off as I'm also working on the radio, ready to scratch the brand new paint job up as I'm moving things around, right? This is the switch for the different bands. So this lights up the appropriate little pointer on that movable scale that was just rewired. So you can see as you move the band switch, this contact here will touch this one, or this one. So it goes like this. And that gives us our little arrows that light up. I've rewired everything the same color as what's here. So yellow goes to yellow, red goes to red, white goes to white, and black goes to black. And that should make things a lot easier on me. The tuning assembly has been completely rebuilt and reassembled, and now this is ready to go back on the chassis again. So both of the variable resistors, the tone and volume control right here, and here, have been cleaned, taken apart and cleaned. And the presets have been put back on, and the gear has been timed correctly with the switch here. So when this is in its appropriate position, this switch is in the correct position. So very important to take notes when you're taking this stuff apart. So for those of you, if you have taken this thing apart, when this is in its extreme clockwise position, so it won't go any farther, and this is pointing to about 11 o'clock, the first black lead on this side is selected, and the first white lead on this side is selected. And then as you rotate it, it will select like this all the way down. Just in case you've taken yours apart and didn't mark that down. So the cap is being cleaned and new resistors installed. They put some light shields on top of the bulbs as well to stop the bulbs from shining on the back and then partially illuminating the other arrow. So that worked out quite well. And that's about it. So it's ready to be installed. So I'll get this back on the chassis and start working on the chassis, getting that all wired up as well. I figure before I put in the oscillator and antenna coil assembly, I should probably test this capacitor right down here because it's right up against the chassis. And of course, I'm not going to be able to get down in there to desolder this if I need to get this 200 picofarad capacitor out. That's 200 picofarad. This one up here is the same capacitor, 200 picofarad as well. So we'll test them both. So I'll turn this on and I'll put the positive lead here and the signal lead here. And that's very bad. So that is the last light on the red scale. After that, it goes to the yellow scale and then counts down an entire yellow scale before this goes green. So that 200 picofarad capacitor is leaking. So let's test out the exact same 200 picofarad capacitor, but on the top side here. Let's see if it's okay. And as you can see, I have them both unhooked at this point, ready to test. No problems with that 200 picofarad capacitor. Isn't that funny? The one that's hardest to get is the one that's bad on the bottom. Oh, by the way, on a normal leakage tester, that capacitor tests fine. So this goes to show you, this thing is worth its weight in gold. I would have put this thing back together and that would have been an issue that cropped up. So, yeah, well, it's an issue right now. So what a pain. So, yep, just hit the, turn this off and test it again. And as you can see, no problems. I'll move this down to the bottom, to this cap right here. What a pain. Shut it off, discharge it, turn it back on, same thing. So, very faulty. Let's test it for capacitance. How does that sound? Let's test the good one first. Put the red lead here, black lead here, and we'll go to, say, 2 nano. Get this so that the leads aren't touching. Pretty close to 200 picofarad. There's 2 or 3 picofarad of parasitic capacitance in this because of the posts, so it's almost spot on. All right, so to give you an example here, I'll just remove the leads, and you can see the parasitic capacitance inside the meter. So I'm on to 200 picofarad scale. It's about 3.4, 3.3 picofarad of parasitic capacitance in here between the parts. So this is over the 200 scale right at the end, so 202. So this one at the top is almost spot on. Very, very close. I wouldn't expect it to be any closer. So let's test the one on the bottom. The bad one. And that tests at 215, 214, 213, something like that. I guess it just depends on how I move the meter. Again, there's some parasitic capacitance in there, so it's probably like 211, 212. And the added capacitance is most likely due to the leakage resistance. So these things use time to tell you the capacitance. So basically it's measuring the amount of time it takes to charge this capacitor, and it's doing some math inside to give you a capacitance reading. If there's leakage resistance inside the capacitor, it takes longer to charge, therefore showing you a higher reading, hence the leakage in this capacitor, which a normal leakage tester will not show you. My eye-tube tester will not recognize this problem here. So I've done this many times. I've compared the two, so you can see this in my other videos as well. So this thing is worth its weight in gold. If you're interested in building something like this, definitely check out Patreon. All the plans are up there, schematics, circuit board layouts, and everything all ready for you to build something like this if you're interested in being very thorough about testing certain things like this. So I'll get this capacitor changed and test some other ones on here and get this thing reinstalled. The vinyl grommets are installed in the chassis so the tuning assembly can sit on the top. So it's a vinyl grommet and a half. So this vinyl grommet is in the chassis, and then I cut a vinyl grommet in half and put the other half on the top to get the clearance right. Now, this little collar sits in the center of the original factory rubber grommet, and as you can see, it's just a little bit higher than the vinyl grommet. So one half of another vinyl grommet, and the collar is inside, but it allows this to compress just a little bit to hold everything tight. So that'll work very well on the upper portion of the chassis. So what I do is I cut a vinyl grommet in half. I stick a drill bit that's the exact diameter of the inside of the grommet, and then I put a sharp knife on here and I just roll the knife and it cuts this perfectly. And then I'll just separate this down here on the bench. I've got this here. So what I do is I take the upper half of the rubber grommet, the one that's been cut in half, and I put a dab of super glue on the bottom one. I stick this collar in here just like this so that it's perfectly centered. All right, I'll just use this as an example. And then what I do is I push this down on it like so, hold it tight for just a moment, let the super glue onto the vinyl grommet. And then before it glues to the metal collar, I just poke the metal collar out, and then it falls down inside the chassis. And then this here, right, this piece here is now glued to the other grommet. So the vinyl glues almost instantly on this, whereas it doesn't glue the collar very quick, so you can push the collar out. And that gets the alignment perfect. Now, the reason that I glue them is because if you don't glue these things and you put the tuning mechanism on, trying to put everything together, get the collar in, keep these, correct, centered and everything is just falling all over the place. So a little dab of super glue will keep you sane as you're putting this thing together, because it can get very frustrating with things falling all over the place. So that's that. So I just got to get the tuning assembly onto the top now and attach the ground straps and on to the next part. Well, hi there. It feels like forever. It's been 5 days since the last video shot, so you can see a lot has happened in that 5 days. So I've got the underside of the chassis completely wired, and as you can see, it's pretty much ready to go on the top side. So I want to share the first power up with all of you. I don't even have a line cord on it yet, so what I'll do is I'll just clip a line cord onto the transformer or something like that. And another thing, while I'm working on it, it's kind of a pain to have that cord hanging off here, because whenever I'm flipping the chassis around like a million times, the cord's always flipping around, and it is a reproduction cloth cord, and I don't want to damage it, so I just clip the cord onto the primary of this transformer. I also have to install a fuse and do all that stuff. Haven't installed the tube socket for the I-tube yet. So this here will be the I-tube driver. So I'll try and disguise that like one of these tubes here. Maybe try and find another spray shield type tube or something like that. Come across that when I get to that point. But everything else is, it's all coming together very nicely. Everything cleaned up nice, and the chassis is the paint is set. Same with the IF transformers and the main power transformer and everything like that. So what I'll do is I will turn this around. I'll show you what I've done on the front, and then we'll take a look at the underside, and then I will continue. We'll power this thing up together and see if this thing makes any noise after completely being taken down to, well, virtually nothing except, tube sockets and a little bit of wiring, which is now almost all completely replaced. Here's how all that new wiring attaches to the front of the radio here. So this is that little switch that's controlled by this arm right here. So originally, what they had, it was just wiring that ran out of here, and then just basically a single wire. And what it did is, I'll just move this down here so you can see it, it's soldered to this point right here. So that wire from there was continually moving like this, right? And that's quite a bit of travel for that wire to be continually moving, and eventually it's going to snap. So what I did is I took some very high strand count silicone shielded rubber, well, it's a silicone rubber test leads, very, very high strand count in here, very, very fine little fibers of copper inside this. So very, very flexible, designed to be continually bent, right? Because it's basically a test lead. And then what I did was I measured this so that when this goes up, it doesn't bind on that screw. It's actually still free here. You can see that, and there's still a lot of room. So when I do this, all it's doing is basically unwinding, and there's very little travel. You can see that this virtually stays straight in this area. See that? So there's very little flex on this point here. So this is just a solution to stop wear. Now, of course, you'd have to turn the band switch a whole lot to even break that other wire off, but this will probably last another 80 or 100 years or however long this thing is around. It's virtually, there's no movement there at all. This screw down at the bottom here, there was one up at the top that holds this little wafer board on. So what I did is I replaced that screw with a little post. So it's a ceramic solderable post. And as you can see, if I move this around, see how that virtually stays straight there and there's no flex at that joint either? See that? So the only movement is in the real gradual rounded portion of the wire. So that should last a long time. Now the antenna transformer sits right at this point right here, the little can that sits here, and I'm going to replace that. But there's a good chance that I may not use that transformer for reasons that I'm going to show you here in just a little bit. So the filament leads come out here, go to here, and then it's a tie point. These leads run off to that light that's on the front of the radio. So this pokes through the front, and I would put that little lamp on and then push this back. And then this here just sits off to the side. Matt's kind of slippery here the way I'm holding this. I have to remove the rear tubes, as you can see here, because if I lay this back, what happens is those tubes, this will lay on those tubes, right? So, and anyways, there's two separate filament strings here. So there's a filament string that runs up to the lamps, and there's a separate filament string that runs up to the actual needle pointer, the little pointer needle lights here. So these are separate. And then these are separate, and they're both on their own wiring system, which runs down in here, and I'll show you that in a moment. You can see the new tab here that was soldered in the front here. So this was soldered before it was painted, and then I just soldered this on later on. You can see the new filament string here for the, you could call it filament string for these bulbs. Runs here and then underneath the chassis. So what I need to do now is I need to turn this, upside down, but I need to brace this. So it's without the filter capacitors and everything on the underside, there's a big gap in the back. So I have to prop the back side of the chassis up so it will stay even. So I'll get that done, and then I'll talk a little bit about what's been done on the underside. And if you're restoring a radio, you can use some of these hints to maybe help you through your restoration. Again, this has been about 5 days, maybe a little over 5 days that I've been working on this since you saw this as a bare chassis. So lots and lots of time went into this. It really it takes a lot of patience is all it takes. And just taking your time, as you can kind of see right here in the corner, right down to the bottom here, you can see how much wiring there is. Lots and lots of redone wiring. Okay, I'll get the chassis flipped up and I'll be right back. Here's a closer look at the underside of the chassis. So lots of stuff done here. So first of all, the little button cells that replace these have been soldered in. I'll tip the chassis on the side here in a little bit and I'll show you this. And also that neutralizing wire, the little gimmick capacitor under here. Also show you that. So you can see that these little holders are empty, and that's because the button cells, the newer ones, don't fit in here, and the polarity is reversed on top of that. So the new little button cells are just soldered in place, and they're on 2 little leads. Again, I'll show you that in a moment. Now you might be thinking they're batteries, why are you soldering them in? Well, there's virtually no draw on those batteries. And to tell you the truth, these little old batteries, a lot of the times can be revived, and they come back to life. So there's a little bit of a trick to that. I'll make a video about that, and I'll show you how to bring the little button cells back to life. Now, the reason that I've replaced these here is because I plan on using this, and I would like this to stay in service for years and years and years. So I just want to replace these with a known part that is very, very good quality. So little button cells that I replace them with are these ones right here. So they're little silver oxide button cells. And yeah, so that's how those are installed there. Now, of course, if you're going to go soldering any type of a battery, you're doing so at your own risk. I've been doing this for a long time, and I have a special procedure for doing that. It works very, very well. These button cells, they get hot really, really quick, so you got to be careful with them or you'll destroy the button cell. Again, if you're going to solder any batteries, be careful, and you're doing so at your own risk. There's one here and one here. As you can see, all the new caps are installed, and the chassis itself has got lots and lots of space in it once everything is optimized. The new filter capacitors are right here. So you can see these 2 holes. These are for the existing filter capacitors that are just basically, they're dummy capacitors. They just fill the holes. So I've left these open here. I haven't put them back in yet. Reason being is when I'm working on the chassis, having those 2 capacitors protrude from the top side of the chassis really limits what I can do with this. Again, if I lay this backwards to work on it, it lays on the capacitors, so it actually puts weight on the caps. So I wanted to keep them out. This way it sits flush on the back side of the chassis, and everything is okay. So I don't need to, go about basically breaking the threads off of those capacitors. This is pretty heavy, especially with that 25 and 60 cycle transformer right over here. So as you can see, the wiring has been all cleaned up. All of the filament leads are twisted together, and they're running in the corner of the chassis. And over to this point here, this is the tie point for all the filaments. The factory filament leads that are this cloth type wiring is absolutely fine. There's nothing wrong with that wiring. So I left the factory filament leads in, and that's pretty much the only wiring aside from the transformer. And, some slight, odds pieces of wire, I guess you could call it single wire, in the actual oscillator and antenna assembly. That's it. There's really everything has been replaced. The wiring in the transformers, as you know, has all been replaced. The new IF transformers are installed. I've installed a few more decoupling capacitors in here in places that they should actually have been from the factory. I think the person that worked on this radio or that put it together, maybe her name was Gail. That looks like Gail to me. And the other radio chassis, which I have as well, I thought, hey, I wonder if there's something written the same in that chassis. And there's the same name written in the other chassis as well. So maybe this was a person on the assembly line. I'm not sure, but really neat at any rate. So I wanted to leave that in there. I didn't want that to go away. That's kind of neat to see. So it was very common for people on the production line way back when to sign their name in the chassis when it was done. Now, where else can I mean, there's so many things here. So the standoffs installed here. Again, decoupling caps. This here is another binding post that I'm going to be using for this right here, which will be the I-tube driver. So this will fit in here, and I can just run the components off of this, so that's the reason I ran the B plus line over to here. All the factory colors are correct, so basically what they were, aside from some slight changes, they had a green wire running up to, this is the negative supply for the grid of the 6F6. I made that blue, it was green, so just to make it stand out from the rest of them. So that and that runs up over here. This sets the bias for the 6F6, which will have to be checked to make sure that the 6F6 is within operating parameters. So I imagine these are very close to the factory values, but I definitely want to double check that. Now, you will notice that if you're going to ever restore a radio like this, you'll notice that most of these old radios, they're 110, 115, something like that, sometimes 118, 117. They have all sorts of different voltage ratings. So you'll notice that the voltages are a little bit higher, and the little bit of difference is not going to be, any big issue. So, if it's a 6.3 volt filament, you might be up to 6.4, 6.5, something like that. And, if you have really, really old tubes in a radio receiver that are just a little bit tired because they've been around since 1930, the extra 0.2 of a volt will light them up just a little bit more and give you more emission. So it's kind of a bonus. You get a little bit more higher B plus out of them. Usually not too incredibly much, but you get a little bit higher B plus out of a radio receiver that's, say 117, 118, and it's running at 120, something like that. So you get a little bit more voltage there. Let's see, what else can I tell you? A bunch of capacitors were replaced in this assembly here. I replaced this cap here on the, this is the mid band here. So there's a kind of the broadcast band, there's a mid band, and then there's a high frequency band. So this is the one that goes to 5 megahertz. This one here was very leaky, the mica on this as well. And I tested this one as well. I opened these up because if you recall earlier, there was one of these that I found that was bad. I figured, I better test the rest of them. And in that, I found a mistake in this assembly from the factory. How I know this is that the lug wasn't even soldered. It was still folded over. So I don't know if Gail put the chassis together, and usually these are all put together in different areas, right? So this assembly would, be put in, and then somebody would wire the chassis, and then maybe another person makes the tuning assembly on top, things like that, right? But whoever was doing this assembly here completely forgot to solder something. So the highest band that goes up to 17.5 megahertz could not be aligned. It would just be static. You could do anything you want with the aligner. It was completely disconnected. So I was very thorough about checking this before I put this back in, because you know what kind of disassembly this would be. And the screws on the top side are hiding under the tuning assembly. So I wanted to make sure all the caps and everything were okay. So I spent a lot of time doing that, because the last thing I want to do is undo these and take that whole tuning assembly off again to get to this. What a nightmare that would be. So yeah, tab was folded over like it was, and it was tinned. So it wasn't even soldered, just folded over and tinned right down in here. So I had to move this coil out of the way and get way down under here, and you can just barely see it here. There's a braid. Let's see if I can point to this. Right here, I'm touching the braid right now. Not this, but this braid right here that runs down to this tab on the capacitor. It's a tab that looks like this. No soldering whatsoever. So it was completely just dry sitting there. It was tinned, but still folded over. So this radio from 1938 could never have been aligned on the 17.5 megahertz scale. So, and of course I'll have to do the alignment and everything when I power this up for the first time. To try and get a bit of signal out of this, I'd like to do a pre-alignment so that I can put this tube in here, that the driver tube, and get the I tube working, and then in the end I'll do a final alignment on the IF and everything like that. So in a moment here we'll power this up and we'll see what happens after all of this work. What else can I tell you about this? Just so many things. I mean, there's just so much time. I moved grounds around, try and make things a little bit closer to the socket, a little bit better for RF reasons. The antenna looks like the antenna transformer that's on the front here looks like it's in a notch filter configuration. So what we'll do is we'll check that. And if it's, if the notch is bad, I don't want to use it. I have a feeling it's going to be. A lot of these older radio receivers, they had notch filters in the antenna section. Reason being is because way back when, in these days, there were some maritime frequencies that were used very close to the IF. And if the IF of the receiver was out a little bit, like say 456, like this is, because, you know, back in the day, 455 had writes on it, so nobody could use 455. So they went up 1 kilocycle. So if, say, another receiver that was very close is at 455, this is 456, that's 1,000 cycles apart, you're going to get a tone. So things like that. So they wanted to make sure that absolutely nothing would get picked up by the antenna, that this thing would not hear any of those frequencies. And that's one of the very, it's a common thing that they did back then. They put notch filters in the antenna, and it looks like that's in a notch configuration. Why do I want to eliminate that? Because usually the notch isn't all that sharp, and what ends up happening is it'll affect the low end of the AM broadcast band. All right, so if I want to use this thing for listening to AM broadcast DX, like distant stations, so skip conditions, that is going to add some, I guess you could say, attenuation at the bottom end of the band. So I definitely don't want that. So chances are that will just be left alone. I might just put the cap on the top, maybe put the transformer in there and just not wire it up. Another thing I'm thinking of is I have the jack here, I think. Do I? I thought I did. Maybe I don't. I thought I did. Anyways, what I was thinking of is because way back when, what they did is they just had 2 wires that came off the front, and they're basically not even twisted together. There's just 2 wires, and they were designed to go out to a long wire antenna, something like that. Now, here's something for you that restore these radios that get lots and lots of noise into your radio receiver. I get lots and lots of questions about this here and on Patreon. And people say, you know, I'm trying to listen to this neat old AM radio, and all I hear is this horrible buzzing noise. Well, the problem is that households nowadays are full of switch mode power supplies. They're in everything, right? Because they save space, and nowadays they're cheap to make. So they're in everything from lamps to, you know, computer power supplies to even like small little wall warts, everything like that. They're all switch mode, and switch mode power supplies are usually oscillating in, say anywhere between 75 and maybe 1 megahertz, something like that. So what ends up happening is because they have square waves inside them, right? It's a square wave oscillator. They create tons of harmonics, and those harmonics are often heard by these receivers, and you get a loud buzz or whine or hiss. Sometimes they're pulsing. A lot of the switch mode power supplies will, when they have no load, will try and start continually. So they'll sit and they'll just kind of go bzz, 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 and you'll hear that in the radio receiver. These are continually trying to look for a load to start properly. All sorts of things. So what I'm trying to get at is the old antenna system was exposed, and it was just 2 wires. You had an earth ground or antenna ground, and then you had the antenna hot lead. So in order to keep things quiet nowadays, the best thing to do is to run coax out and get the coax away from your house, and then, you know, have your long wire a ways away, so it's shielded right up to the wire, right up to the actual long wire antenna. That's what I do with all the receivers here. I run them on coax to a long wire antenna, and by doing that, you can get rid of all of that buzz. I'll demonstrate it. I'll hook that up later, and I'll just disconnect the shield. All right, and I'll let you hear how incredibly bad it is in here. Right, you know how much test equipment's in here, so. As you can see in the intro shot, I'm surrounded by it, and there's switch mode power supplies everywhere, and it's just incredible. Even the monitor that I'm using, that's right in front of me right now for videoing, makes an incredible amount of noise in these old radio receivers. So the bottom line is, what I want to do is I'm going to run some coax on the inside of the chassis, and there's a hole here that just does nothing. It's just here from the factory. You know what? A small BNC barrel fits in this perfectly. I can just poke it right in here, just like this, put the nut on, and then run the coax over, either way around the chassis, whatever way I choose, up to here. And then what I'm going to do is just feed the signal through a blocking capacitor. The reason I want a blocking capacitor on that is just in case anything ever does go wrong with the, wire antenna, it will block any DC, and it will also limit the current if there's AC applied to it as well. It was very common. These are the antenna coils, and these are the oscillator coils, okay? So what happens is when you're on the broadcast band, this is the broadcast oscillator, and this is the broadcast antenna coil. Okay, so this antenna coil is just connected directly to the chassis via this ribbon, and then it connects right to this post. So if any kind of AC or DC with just even the smallest amount of current comes across it, it'll blow the little wires off of this antenna coil, and you have an open antenna coil, and this is so common now. So I've seen so many radio receivers with open antenna coils. So by putting a blocking capacitor here that'll block DC and limit the AC current if anything's happening, that, you know, this will be continually protected, so nothing will ever happen to this. And especially down the road, like I've had this radio receiver for quite some time. All right, so down the road, if this radio goes to somebody else, all right, that this way it's completely protected and it's very, very dependable, right? Whenever I work on anything, I want everything to be the best. I want it to be as dependable as possible. Everything is a balance. You know, how far do you go, right? So anyways, so this is the broadcast band. And then the second band, when you click the switch, goes click to these two here. So this is a band that goes to 5 megacycles right here. So the antenna coil, oscillator coil, and then click one more time. And this is the highest frequency right here. So this is the highest frequency oscillator coil and the highest frequency antenna coil right here. How can I tell this just by looking at these coils without even tracing any wires out? Well, it's very simple. The coil with the least amount of wiring on it is the highest band. All right, so the higher you go in frequency, the less wire that's wound on the form. So the second one down is this one here. All right, so this has got the second, I guess, least amount of wiring on it. I guess looking at it going this way, the least amount of wiring, and then this one here has the most. So the most wire is the lowest frequency. So if you have a bunch of coils on a switch, and you can really see the number of turns difference just by looking at it, this is very noticeable. You can tell what the bands are, and you can even tell the antenna coils the same way just by looking at that. So remember, low frequencies, more wire. High frequencies, less wire. Same thing goes for transformers. High frequencies, less core, less wire. Lower frequencies, more core, more wire. Okay? Right, because you have a bigger core, there's more wire wrapping around it, right? Whereas if you have a switch mode power supply, it's much smaller, right? And you have a lot less wire wound around that little core because it's working at a higher frequency. Okay, pardon the shaky radio because this is just balancing on one corner of the dial frame here. And there is no glass in that dial frame while I'm doing this because it's very dangerous to have that dial glass in there. So, one move and that dial glass cracks. Very, very sensitive thing to be working with. And after all the movement I've done, you should see the frame. It's bent back a little bit because of just all the chassis movement, so I'll have to bend that straight again. It's just stuff that you just can't avoid by this amount of work. So this here is the IF transformer lead from one stage, and then from the next stage we have this feedback path that runs here, and that's the gimmick capacitor wound right around that wire. Now the wire is spaced away from the wall of the radio, and it's in free space here. It's not around any other wiring to get the most amount of coupling and to basically get rid of any issues. You can see that this area is completely cleaned up. The cleaner the area and I guess you could say the more the signal leads run across the chassis and they're close to the chassis, the less chance you have of the IF section breaking into oscillation. So this is all just good design practice. That's all that is. So when I was changing this all around, I could move all of this stuff here. Just let me get this lamp out of the way here and get this one in here so that we can see what's going on. Pardon the noise and all that. There we go. So it's just good design practice, and when you're going through this, you want to clean things up the best you can. Now, keep in mind, way back in the day, they had lots of very large components, so it was harder to optimize these things. Nowadays, the components are so small, and you see the capacitors here. They're very, very small, and they can be very easily tucked into place. Now, you know, even the filter caps, which are right here, are very, very small. They're just on this little terminal tie strip here. It really cleans things up. You see how much space there is in the radio receiver. Let's see if I can show you that mistake. There's the braid right down in there. See that little piece of braid? It looks a little different than the rest of them. Let's move the focus on that. Okay, there we go. You can hold that steady right there. The braid right underneath that black wire. That's the lead to that capacitor that wasn't hooked up. So it's just, hold on. Sorry about the shaky radio again. It's just one hand and it's balancing on the corner here. So right here, this is the braid. This is the tab that was folded down. So this was folded right up against that little piece right here that you see. So I had to move wiring out of the way and then fold this up. So it required the removal of this coil here to connect that to this point here on the switch right here. So there would have been absolutely no alignment on the upper band, which would have been an absolute pain. So usually what I do is I clip one of my test leads, my signal, the pickup lead for the SA goes to this point. So what I do is I put this around here like so, just like that, all right? See that little piece of pipe is now on there, right? And then what I do is I take an alligator clip from one of my protection device boxes, and it's also an attenuator, and I clip it to that so that it doesn't damage the wire, because the alligator clips, they've got the teeth on them, right? And they'll dig into the wire. So I clip it to this little piece of fibrous tubing here, and that capacitively couples to the detector lead, and the signal comes off of this and goes into the SA. So that's where I'm picking the signal off, and if I turn this back over again, turn this around, the signal is injected from the tracking generator right onto this right here. So again, I'll put another piece. This is just here to cover the soldering connections, to basically dress things up. This here is a piece of Teflon coax now, by the way, with some dress on it so that you can't see the Teflon. At any rate, I'll talk about that in a moment. So what I'll do is I will get another little piece of this and just put it around here and then clip the tracking generator little protection box onto this right here, and it'll inject signal right into the grid of the tube, and then it'll go directly through this. Acts as a bit of a buffer, goes through the stage, and it gets picked up at that detector wire, the green detector wire there. So let's see. This here is some Teflon coax. I don't know if I have any of that around. I'm just going to set this back. As you can see, no dial glass yet. Let's see. Back here, and yes I do have a little piece, a little tail that was left over. So this is the Teflon coax that I use. Now the nice thing about this is you can solder this and nothing will ever melt. So I can solder this to areas, and you can even solder the braid along pieces, the internal pieces of the chassis. So you can solder this in different spots if you want. It's a nice thing about using that. Well, this is a piece of Teflon coax here. And the center conductor is very small, so what I do is after the shield is tied to the chassis, and the shield runs up to here and it's trimmed off. Okay, so the shield is just up to this point right here. And then after that, there is some heat shrink tubing that goes over the end of the shield all the way to the center conductor that's up to here. So there's two pieces of heat shrink tubing under here to make it more rigid, because that's a very thin little Teflon wire in the middle, and that's soldered to here. So by doing that, it's rigid like the rest of the wire, so it won't break. Now mind you, this stuff is very flexible, and this is really high quality stuff, but it's always nice to have that. And the lead is long enough so that you can put the tube in. So what I'll do is I'll just put this down here, move this over. So you can put the tube in right here, which is a 6F5, like that. And then you can just press that down, and as you can see, there's enough that you can comfortably remove it, and there's not too much so that it's got a big bow in it or anything like that, right? So that worked out very well. That out of the way. So going back to the bottom side of the chassis here again, let's see, move this around. That big transformer sure makes things awkward. Heavy chassis. Turn this upside down like so. So that piece of coax, I'll just back this out here a little bit. That piece of coax runs up through that hole in the chassis, and it's soldered right here to a lug. And then I put some more of this fibrous tubing over top, and then it just solders over into here, where it's the signal goes into the grid, right? So it has to go through a bias cell, and then it goes into the grid. So they're giving the tube a little bit of bias from the battery. Now these batteries will, again, virtually, they never go bad. There's no current draw on them, right? It's like a battery in the gate line of a FET. There is no current on there. There's no load, basically. It's the same thing with a vacuum tube. So the batteries, they last an extremely long time. I expect these just to last the term. They're sealed up very well. So the way that they're put together is much better than a normal button cell. So those batteries that I showed you are very high quality. They're kind of pricey, but it's worth it if you don't want to go back into the radio receiver again. So that's that. There's so many little things that I could spend, talking about the time. As you can see, I replaced the braids here, right? There was copper strapping here, but I wanted to solder in some new braid because that copper strapping was pretty mangled. So I guess throughout time, it's been, handled pretty rough. I used the same wire that they used. Basically, it's a shielded wire that runs up to the controls up here. You can see that. Runs up here. I left the factory tape up here. I wanted to see how they had shielded this inside, so I took the tape off. You can't really see. Can you see it here? Yeah, I took the tape off, and there's a piece of heat shrink tubing here. That's this is some heat shrink that I put back on here to replace the tape. And then, of course, there's heat shrink tubing at the ends of all this cloth wire that's been installed. You can see that there's some heat shrink tubing at the ends because this stuff likes to fray. So by doing that, it just allows you to work with it, and the wire doesn't fray, and it it just stays good. Let's see, what else can I... There's a little bit better view of that switch. So the little contacts. The tension of this has to be set. So basically you set this down in the middle so that the little... there's a little contact there. It sits flush in the middle, and just give it just a touch of pressure, and then tighten up one of the little set screws here, and you can move it around to make sure that it aligns correctly with these little contacts here. And then, of course, what happens is that once it comes to the contact, it rides up on the contact, so it puts more pressure on there. So there isn't a whole lot of pressure. It's kind of again a balance, because if there's too much pressure, of course, it wants to stay in the middle, right? You find a kind of a detent in the middle, so you want to make sure that it actually finds it uses this here. You can see a little cam in here with a little ball, so that it actually uses that so you can feel it. And you don't want to be feeling that portion, the center portion. You want to be feeling it when it actually goes into the band position, right? So if you push this too tight down there, it'll override this, and it it kind of aligns to the center of the little contacts. Something you learn as you're going through this and setting up the tension and everything. I think that's about it. I think that's pretty much all. So now, what I'm going to do is turn this over carefully. I'll grab the transformer here. And what I'm going to do is put those tubes back in. Turn this chassis around. Got to be careful the way you grab it. These are the IF transformers are very soft metal on them. And they are metal, they're not aluminum. And they're very soft, so you definitely don't want to be pinching these things because they will dent and they will stay that way. Just from tightening them in just a little bit, you can see it puts a bit of a twist on these, and that's the way they are from the factory. They have a bit of a twist. So you need to tighten these down so that they're, solid to the chassis. This one here actually has a ground through the case. So for the feedback winding on this transformer here, there is a what's it called? A ground. You can't really see it on the bottom, but there's a ground that grounds through this case. So it's important that everything is nice and tight on the chassis and things like that. You see the alignment tools? You can see how that one screw, if something was wrong with this, that screws under this platform. So you're just going, at that point, you're going, oh no. So you want to make sure everything is done correctly. There's the other screw on the other side there, and the other one is, as you can see, it's hidden under the platform as well. So getting to the alignment points in this will be fun, because these are 1/4-inch alignments, and you got to keep in mind this is 1938. So what is the term for the alignment tools? UG smash. I think that's the term for the tool. So it's basically a 1/4-inch socket down in here, and I can give it a turn, and that's the way that these things align. So there's no finesse in this alignment here at all. So another thing I'd like to say about this radio receiver too is you got to keep in mind that the radio receiver is neat. The dial on this is it's a absolutely beautiful dial. That's the only reason I've put the time into this receiver, is because that dial. That's it. It's one of the nicest radio dials I've seen. And as you can see, as I was talking about, see this here? See that? That's very simple. You can just grab this and give it a bit of a push and it straightens right up. So that's because of the weight of the transformer, right, on that. See that? Just about straight now. So not a big deal. But if you were to tighten the dial glass down into this and not realize that, the dial glass, you'd put a crack in it right away. So what I do is I'll run a ruler across this in all directions and make sure that it's absolutely flat before I set the dial glass down on it, because again, I don't want to destroy that. At any rate, back to the thing here. So the dial on this is absolutely beautiful, and it's the only reason I put the time into this. Now you got to keep in mind that this radio receiver is nothing more really than an All-American 5 design with early tubes, right? It doesn't have an RF amplifier in the front end. It's basically just a 5-tube plus, because the rectifiers and such, super heterodyne, single conversion super heterodyne radio receiver with a magic eye, right? So, by putting more rectifiers in, I'm sure, Rogers and DeForest, they up the tube count and they, make it look that much better, right? Only 2-gang tuning capacitor, whereas if you recall in the previous video of the Stromberg-Carlson, there was a 4-gang tuning capacitor in there. So performance-wise, comparing this radio to the Stromberg-Carlson would be extremely unfair for this radio. This radio is very simple. So I'm going to tell you already, I know that there's going to be image frequencies on the band, so we're going to hear signals in 2 spots, things like that, just because it's a very simple design. If you watched my Echo Phone EC1 radio receiver, this is the same kind of idea with a rectifier, different rectifier setup, and that it's very, very simple, very, very simple basic receiver with an I-tube. That's all it is. Again, the only reason that I spent so much time on this is because of the beautiful dial. It's just, the dial is stunning on this thing. So nicest dial, I think. Yeah, I'd say so. Nicest dial on any radio receiver I think that I've ever seen. Now, of course, now that's subjective. Everybody has their own opinion on things, but just the way it looks with that kind of a sunburst look to it and the eye in the center, and of course the little needles, the little lights, arrows that move around is just, it's just a really neat design. If it had an extra, say one extra part to the tuning capacitor, so it had, say, a tunable RF stage in the front end, and just things like that, it would have been, this receiver would have been really something to write home about. But again, it's just a very simple radio receiver. But when I power this thing up and get it all tuned up, we'll test it out and we'll see how well it performs. So I might be being kind of hard on this radio receiver, but just through experience and rebuilding these things, you know where you're at. So that's that. So what I'm going to do now is get this thing, I guess, maybe laying on its side. That'd be good. So I can face the bottom portion of the chassis as I'm putting power to this thing, and let's see if it comes to life. So that is a whole lot of work. So hopefully it does come to life, and if not, well, we'll troubleshoot the thing and make it work. And then once I get it going, I have to give this a pre-alignment, and then the next step is I'm going to try and get that I-tube in here. So there we go. I'll get this thing onto its side. Let's power the thing up and hopefully not make any smoke. No smoke. No smoke. All right, let's see if this thing comes to life. So volume is down. And is this on? Okay, it is on. These are very, very rough to turn. Okay, so I'll leave that on. And I put this wooden knob on the front here so I can tune the dial easier. This is pretty tough to turn because of the gear reduction unit. So, and it's in the broadcast band, so that's up, and that should be okay. So what I'm going to do is turn on my dim bulb tester right now. So it's an isolation transformer and current limited variac supply. And what I'm going to do is let this warm up and check the B+. It should be relatively low because, this radio is going to draw a bit of current. It's got quite a few tubes and stuff, and I don't have very high wattage bulbs in my dim bulb tester, but let's see what happens here. Let's turn it all on. And yes, those bulbs are not dim. So they're glowing pretty bright. So let's see. This here should be a nice clean point for DC. Yeah, there we go. Not bad. So this should rise, and then it should start to fall again as all the tubes start to warm up. It's very standard. And that's going way down. The reason this is coming down like this is most likely the 6F6. So the 6F6 is the one tube that draws a lot of current. So that is the main. Let's check the actual plate supply. Yeah, it's there. Okay, so that's the screen. So it's looking pretty good so far. So what I'll do is keep that on there. So we're at 48 volts. So now what I'm going to do is I'm going to bypass the bulbs and go to full power. And that's looking more like it. So now the tubes are still going to warm up some more. The filaments are going to come in. Okay, so what I want to do right now is check the bias, make sure that there is bias on that tube, and yes there is, 19.4 volts. So it's negative 19.4 volts bias on that tube, which is fine, that's what it's supposed to be. So there's no smoke, which is a good thing because there's no load on the B plus here, or, you know, excessive load I should say on the B plus. So it's all there, so we have the B plus here, 258, and you know we have our negative bias and everything. Okay, so I have an antenna attached to this, right? Everything's all ready to go, and it is in the broadcast position. So what I'll do is this is the volume here, so I'll turn this up. Wow. Okay. So what I'll do then. Tone control. Now keep in mind, there's no alignment. No IF alignment, no RF alignment, nothing.
I kid you not. This dominant. Doesn't matter. It's like a big boy guy.
It's almost like I don't need to do an alignment on this. Well, of course I do, but wow. Okay, so I'll switch to another band here. And we'll see if this one's alive. And the oscillator's going. So you can hear static like this. That means that the oscillator's running. If the oscillator wasn't running, there would be no static. It wouldn't be receiving anything. Oh, there's a WWV. Wow. Pretty impressive. Okay, so let's go to the highest one. I believe that's the other arrow. That's that one. The light bulb that's furthest away. I can't see if there's anything going to happen. This is the band that had no aligner. Now, what I did when I hooked this thing up is I don't know where that capacitor was at default, but I did turn them around a little bit because I wanted to make sure that they weren't seized. Again, I didn't want to have to take this out again. So I made sure that they weren't seized up, the little aligners, the little 1/4-inch nuts on the top that you see there. So if they were seized up, that would mean that I probably would have to take the capacitor assembly out again, and again, one of the mounting screws is under the top platform, so I did move them around. Now keep in mind, what you're hearing is a radio that's completely not aligned. So just goes to show you, with all brand new parts, the thing will basically work with no alignment. So anyways, let's see here. And the upper band is working as well.
California.
Wow. Pretty impressive. What do I say? I have to give it a bit of an alignment just because... Turn that down. I have to give this a bit of an alignment just because I want this to be, you know, somewhat peaked up while I'm doing the I-tube, right? So I have to install that tube socket into the chassis here and put the I-tube in it and everything like that. So I'm going to have to, you know, make sure that the IF is somewhat, you know, decent, you know, just through the peaking method. I'm not going to worry about SA aligning it at this point. I just want everything peaked up so that I can make sure that when I design the circuit for the I-tube that it's going to operate correctly. So, and then after that I'll end up doing an alignment on this thing, but wow. So let's see what happens if I open the ground. Remember how I told you if you have just two wires and you have just an antenna wire hooked up, how I'll pick up switch mode noise? Let's see if I can demonstrate that for you here on this band or some band. Hear that? Hear that? So that's with just an antenna hot lead. So what I'll do is I'll now attach the shield or the ground so it's shielded right up to my antenna outdoors right now at this point. I can actually hear a radio station in the background now. You see, so this is a common problem with nowadays, and this is the reason that basically I'm going to run that piece of coax to a BNC in the back, and then that way I can use an antenna that gets the antenna away from the house, let's put it that way. There's no bare wire around the house or, say, you know, the shop or wherever this thing is going to live. So I imagine this thing is going to live at the house because I'm, you know, spending so much time on this thing. But yeah, there you have it. So what I'll do is I will do a pre-alignment on this thing. In fact, I'll show you the I-tube bracket and things like that, and then I'll do my pre-alignment, and I'll get that all attached, and then I'll come back with everything all working again and show you how that works. So far, it's pretty amazing. This is a good example of a completely rebuilt radio. So virtually no alignment, nothing at all, and look at how well the thing receives. All brand new components aside from the oscillator coils and, you know, IF transformers and things like that, but just, you know, all brand new components everywhere. And the speaker, it sits silent, like zero hum. Can't feel anything in the speaker at all. So there's an example of a radio that's been almost completely rebuilt from the ground up. Works just from basically turn on. The radio receiver now has a preliminary tune. So I've pre-tuned the IF, pre-tuned the oscillator, and pre-tuned the antenna stages, and the radio receiver works even better. Really surprising from what we just heard in that previous video clip. It's amazing how well this thing performs. It's surprising me, this little radio receiver. So this is the original I-tube that was with this, and if you recall, it fits up in here like so, and then there was a little clip that held it like this so we could see the I-tube from the front of the dial through that hole in the dial. So obviously these things are long since bad, as explained many times, so the new I-tube is going to be this one here. So in order to make this stay where it's supposed to be, like this, I needed to fabricate a bracket. So what I did was I took the old bracket and I welded a little tab onto it. So I TIG welded this in here. It was fun getting the TIG torch in this little area here. And just painted it up. And that's it. So now what'll happen is, I also drilled a hole here. And that's threaded to 832, which is the factory screw that threaded in here. So now it will thread back here. And it threads in there very nicely, as you can see here. So that threads very nice. So now what I can do is grab this and just give you an example. So I'll put this in here like so. Clip that on there. Okay. And then put this in like this. And I'll grab this. Do this like so. Like that. And as you can see, it holds a new I-tube in. So this can be adjusted. You know, I can adjust it back or forward. And of course, the actual tube itself in the socket, in order to get it centered, you can move the actual little tube around in the socket just a little bit, and you can really get things centered, but it's pretty close just the way it is. So just like that. And now this will run, if I move this, gotta be careful how I move everything here. See the eye tube in there. Worked out pretty well. I'll put this here. So now, this wiring harness, as you can see I've left lots of wire here, will go through a grommet through that hole and to the underside of the chassis. And then, I have to install that, that little tube socket down here, and that will be the driver for the eye tube that's in the center. So I'll get all of this happening, get the tube socket installed and the eye circuit working, and I'll come back and show you how well it works. And the eye tube circuit is complete. I'll just quickly move through the band here and give you an example, and then I'll show you the circuit on the bottom portion. This is the tube right here that has been added. So here we go.
Mailing address is on our website. You'd be better off gone. Live is employment benefits. Just some of them.
There's a kiddie.
The good news.
Public interest.
One, they launched their network of retail. This is on your end. Taking control. Is this? Model as well.
Lots of stations, because this is late in the evening. Lots of stations on top of each other, but works very well.
As you can, but it's on DCs today. It's actors like
Calories I took.
So there you have it. So what I'll do is I'll get the chassis upside down and I'll show you the circuit on the bottom portion that drives this eye tube. This is the tube socket that's been added into a pre-existing punched hole in the chassis, which is kind of nice. So that allowed me to add this DC amplifier, or if you'd like to call it a control tube for the eye tube, whatever works. So this is a standard pentode configuration. So the suppressor grid is grounded, the cathode is grounded. The screen grid has a voltage divider on it, and this is what sets up the sensitivity of this tube. So this tube can actually be used in many different radio receiver scenarios if you wanted to use a dual shadow angle like a 6AF6 like you saw. All you have to do is really tailor this one resistor right here. So to give you an example of the range here, well, first of all, I experimented with the 6SK7, which is a remote cutoff pentode. It was okay, worked all right. You can tailor the 6SK7 to work very close to the 6SJ7, even though the 6SJ7 is a sharp cutoff pentode. The reason that I did choose the 6SJ7 tube is the action of the tube is much nicer for the lower AVC voltage that's available in this radio receiver. So for example, the AVC voltage that this creates is about negative 0.4 volts, which is no station, no antenna attached, just sitting here, okay? And then with an antenna attached and a strong radio station coming in, it'll go up to, say, negative 3 volts, or if you like, down to negative 3 volts, all right? So basically, when it's sitting at 0.4 of a volt or around there with no antenna, we need the eye tube, we need the shadow angle to be open, all right? And then when we have negative 3 volts with a strong radio station, we need the shadow angle to close or slightly overlap. And this tube in this configuration allows me to get that. And it also allows, when the noise floor is low, for the tube basically not to even do anything. It kind of sits there, it'll move in a little, you know, but very little. But as soon as you have a radio station, it kind of pops in. Even for the very weak radio stations, it gives me, you know, a little bit of shadow angle deflection, which is very, very nice. Now, the way that the eye tube works in a radio receiver is really subjective. It's basically there as a tuning aid, and it's, of course, there to add pizzazz to the radio, right? To make the radio look really neat. So when I was setting up the screen grid voltage on this tube, the screen grid voltage variation between about 29.5 volts to 35 volts was the range that I wanted to be working within. So if the screen grid voltage on this tube is sitting at 29.5, the slightest little noise or radio station will cause a little bit of shadow angle deflection, okay? So if you're tuning in on the shortwave bands and there's, say, a really weak signal, you're going to get quite a bit of movement there, which, of course, is desirable, right? But the problem is now is you're dealing with a balance. Now, what happens when you come along to a very strong radio station? Well, the thing's going to close really quick, and if not overlap, right? The shadow angles will do that. So if I up the screen grid voltage on the 6SJ7 to say 35 volts, what ends up happening is that it's not, I wouldn't say desensitized to a regular iTube, but if you have a really strong radio station, it's going to be very close to being closed. But you need to really have a strong radio station, a flamethrower type radio station to overlap the eye. But the problem is with that is now if I'm tuning around on the short wave bands, I don't get that little bit of action when I'm trying to tune into a really weak shortwave radio station. And that's where the iTube is really desirable, because the strong radio stations, it's there, right? The iTube is just going to close or whatever. You don't really need a tuning aid there. But on the weak stations, you want that. So what I did is I kind of went in the middle. So I went with about 32.5 volts. Now, because there is no regulation in this radio chassis, that took quite a bit of experimentation, because if there's any line voltage variation, what ends up happening is, of course, the screen grid voltage will go down and the tube gets more sensitive. So, and if you have too much line voltage, the radio receiver will get more screen voltage on the actual 6SK7s, and the plate voltage will go up a little bit. So the radio receiver gets more sensitive, but it gets counteracted by the screen grid voltage going up on the 6SJ7. So it was really quite this balance I was playing with. So at any rate, by grading some resistors and getting values very close to what you see, these are right on what they say they are, all right? So this is an 82K resistor. That is a 15K resistor, right on, almost right spot on. I got my about 32 to 32.5 volts on the screen grids at about 120 volts AC line, and that's a nice average for the AC line, okay? Now, that gave me a very desirable iTube display in this radio receiver. Now, I'm going to dedicate a video to designing control circuits for iTubes if you want to use different types of iTubes. So I can keep going on and on about this little circuit here, but I think it would probably be better for me just to, as I say, dedicate an entire video to that and give you ideas of how you can control this and what type of circuits that you can make to do this. You can, this works with all sorts of different types of iTubes. And if you have an AVC section in a radio receiver that isn't really producing a whole lot of negative voltage, it's very easy to add in a simple little DC amplifier so that you can, have that variation work within the radio's AVC. So the way that the iTube works in this radio receiver, I've got to tell you, this probably works way, way, way better than it did from the factory. Okay, the 6X6 that was in this didn't have a whole lot of area to work with, so you probably really, really needed strong radio stations way back when to make that 6X6 come close to being closed. Now, keep in mind that all the AM radio stations in the 30s and the 40s were usually strong, all right? So the way the internet is today with all of us, we all have internet and all this kind of stuff. This was the internet for the 30s and 40s. Everybody was listening to radio receivers. So radio stations, they were pretty powerful back in the day. So I imagine the 6X6 would have, had a lot easier time getting shadow angle deflection than it would nowadays. Okay, so there's a lot of things to keep in mind. So I'm pretty positive that the action of the 6AF6 is a much nicer action than the way this radio receiver came. See, what else can I tell you here? I added the coax in, the BNC jack right down here, and I added the coax running over here and up to this point here. So there's a capacitor that isolates the line, so it isolates the antenna line from the antenna coils. So if anything was to ever happen, I'm not going to get DC on the coils. And of course, again, this will limit the current. A bunch of resistors here to discharge the capacitor, so it doesn't remain charged. Cloth line cord installed, fuse installed in the hot line. So the hot line comes directly in, goes right to the fuse. First thing in line is the fuse. Always first thing in line. If anything goes wrong, that's what you want to go away. So a lot of people say, I like to have the switch in line first. Well, if the switch shorts to the chassis or something goes wrong with the switch, you don't have a fuse in line. So always the very first thing in the hot lead, the safest thing to do, I find personally, is to have the fuse in line. So this is an absolute value fuse. So if I was to say short the heater lines, this fuse will go away, or if there's a B plus short in this radio receiver, this fuse will go away. So hot line to the fuse, through the switch, back into the transformer, and then the neutral line ties directly into the transformer. There's a little tie post right here, and it goes in. You can see there's a strain relief I've added to the side of the radio here, a nylon strap. It's very, very tough. You can see I can pretty much swing the radio around by this. It's in there very tight. So I put a bit of heat shrink tubing over the cloth cord just to basically add a bit of thickness, so when I tighten the strap down onto this, it holds it nice and tight against the side of the chassis. There's also super glue underneath this as well to even act as more of a restraint. So there's, I can tug on this thing like crazy and it definitely will not come out. I didn't want to have a knot down here, or I didn't want to have the little zap straps tied around here because there's wiring down here. And I also have to reinstall those dummy capacitors on the top side of the chassis. I haven't put them in yet because I'm still moving the chassis around. So I have to get all of that down in there. So I wanted this spaced away. Whenever you're working on a chassis like this, you always have to keep in mind that in the end, when you put the bottom pan on and you're putting the actual bolts through here, they come quite a ways into the chassis. So you got to make sure that there's a lot of clearance down to the line cord or anything that's underneath these. I see in a lot of designs, people forget about this. So, they'll have wiring running directly under here, and then they're threading in a screw, and then the threads slowly cut through a wire, and you get a short circuit. That's very common in E.F. Johnson, Viking Valiant transmitters, and Heath kits, and things like that. The homebrew things where they would tuck the wiring close to the corner of the chassis. And on the back side of the E.F. Johnson, they've got screws that run around the whole perimeter of the case. And every screw you're tightening in, if you don't have that wiring harness pulled away, it'll auger right into the wiring harnesses. And I've noticed this over and over with radios and things like this that are rebuilt. So always make sure that there's a lot of clearance under each one of the mounting holes, because it's one thing that you'll forget when you're putting this back in. You'll start tightening the screws in, and you'll tighten the screw right into a wire or something like that. Okay? Always something to keep in mind. So that's installed. What else? This is the wiring that came through the rubber grommet here for the eye tube. So the heater lines run to this block here. You can see there's a strain relief here. And I also have a tie strap, which is a strain relief on the bottom side of the chassis. So if I was to pull on the wiring on the top, it wouldn't pull tight down here. So this is just to allow for movement. The same thing as this loop here. This is a strain relief. So if I'm to move the line cord, twist it back and forth, you can see there's just a little bit of movement there, right? Just a little bit of movement up here. You always want a bit of a strain relief. You don't want anything banjo string tight, nothing like that. So always have to keep in mind, because the outside world is, tugging on this, and the inside world is not seen once the bottom cover is on this thing. Oh yeah, I was going to show you this here. So I didn't use the antenna transformer. I don't have the antenna transformer installed because this here, T1, is classified as transformer 1. And this is set in a very, I guess you could say, notchy type of setup right here. So they're using this to basically notch something out. And I would imagine, again, this is probably going to be sitting down around the IF, because again, they didn't want the heterodyning and stuff happening back then from maritime stuff. So what I'll do before I do the IF alignment is I'll hook this thing up to my spectrum analyzer, and we'll take a look at this coil and see exactly where this thing was operating. That should be interesting. So find that out here in a moment. And then right after that, I'll go directly to the IF alignment, get that out of the way, and RF alignment, and then back into the chassis it goes, and we'll be scanning through the bands, and we can listen to see how well this thing sounds. Well, it's a good thing I did not reinstall T1 back into the radio receiver, into the antenna line. Reason being is, center screen is 5:50 a.m. All right, if you watch the dot, I'll move right into the dip here, so right into the notch. That's 900 a.m. So the entire AM broadcast band, this is off to the other side, the entire AM broadcast band is well within the decline of this notch. I'm thinking to myself, this would make this radio receiver completely deaf in the broadcast band. That can't be right. So this is at room temperature, right? So I'm thinking, you know what? I wonder what would happen if I just hit that with a bit of cold spray. So watch what happens when I give the filter. So here's the filter. right? It's attached to the spectrum analyzer, right? So I'll give this just a little shot of cold spray. Okay, so where did we move? Oh, it's moving. It's the temperature selecto notch. So where are we now? 445 kilohertz. So this is really close to the IF frequency. So this is most likely the area that this little filter was tuned into, right? Again, because of the maritime frequencies and things like that way back when. So at room temperature, this thing is attenuating the AM broadcast band really badly. So if this thing was, say, in a cold environment, maybe like a garage or a cold basement, the AM receiver would work fine. But if this was in a nice warm environment, chances are the AM wouldn't work well at all because, it's being attenuated. This is, not a, this is a pretty nasty notch. This is 5 dB per division, right? This is really attenuating signals here. So now we look back at the chassis. The chassis was really rusty, and it wasn't rusty from, basically, like animal urine or anything like that. It's rusty from moisture. The moisture was spread out all over the place. Kind of puts a story together, doesn't it? I bet you this thing was in a cold environment like a garage or something for a very long time, because that's where it actually received. As soon as you brought this into a warm atmosphere, the receive would go away. Interesting. So at any rate, even if this is at the correct frequency, so say this is where it's supposed to be operating around the IF, right? So if I go up to 550, right, 550 AM, which is right here, right at the line, we're still in the gradual decline of this notch. So it's still attenuating the AM broadcast band, right? So this is all being attenuated, right? And it'll go well beyond. If I go stop frequency 1600 kilohertz, right? It's still attenuated right at the end of the screen. We're still in the fall. So as this line is falling, so is the receive. And this is, at the sharpest point of the fall is where the receive, drops off the most, right? And again, at 5 dB per division, this is no mild notch filter. That's a pretty good notch filter. So I definitely don't want this thing in line. Those frequencies down there, the maritime frequencies and all that aren't there anymore, and there's really nothing that's going to be interfering down at that bottom portion, right, around the IF frequencies. So if you have a radio receiver like this, it would be in your best interests to get rid of T1. Just take it out and do the modifications that I did, putting that capacitor in there and everything, and that'll really wake up the AM broadcast band. I'm about to attach my tracking generator output to this radio receiver here so I can do the IF alignment. So the IF alignment involves me twisting these adjustment points right in these two IF transformers. So I'm going to be looking for a peak and for symmetry. So what I'm going to do here is I'm going to take one of these and take this little piece of fibrous pipe that I've cut in half and put this on here so I don't cut into this lead. Then what I'm going to do is I'm going to take my tracking generator protection box, and this is also an attenuation box. All right. So what I'm going to do is just clip this onto here, right? This whole chassis is, attached to the tuning capacitor. What I'm going to do is just clip this onto this lead like so. All right. So you can see how that's just clipped on there, and this will stay here, hopefully. If it slips off, I'll have to move it to a different area. Looks like it's kind of slippery. Maybe I'll put it onto this, there, put it onto that screw that holds the eye tube. That's nice and tight on here. So that's how this is attached. So this is the tracking generator output. So this is the signal coming in, and this is going into the grid of this tube. That signal will go through these IF transformers. So it's going to go through this tube, into this IF transformer, come over to here, into this tube, get amplified, go into this IF transformer, and then go into the detector tube. And the green lead on the bottom that I just showed you with that other little piece of black pipe will be the other spectrum analyzer protection box, which is this one right here. So this will clip on to that little black piece of piping that I've left under there so that I don't cut into the wire, and then this will just get clipped to the chassis. And this will run to the 1 megohm input on my spectrum analyzer, and this will allow me to sweep this. Very important to make sure that if you're ever going to be doing a sweep, that the result is flat. So if I attach this red lead to that red lead, and I attach this black lead to that black lead, so I'm just going from the tracking generator out of this box here, and then through and then back into the input of my spectrum analyzer, I need a completely flat response across the screen. And that's what this provides me. So it provides me protection for my spectrum analyzer. It provides me with attenuation because the signal's getting through here, getting amplified to some pretty high levels. And I also don't want to feed, the output of my tracking generator into this thing without being attenuated, because this is very sensitive. If you put too much signal in here, you start to get issues with your alignment. Again, the whole idea, as I've mentioned many times before, is to keep your test equipment invisible to the device under test. So I want the radio to think that it's operating normally, that it's working normally, but it's going to have a spectrum analyzer attached to it so I can properly align both of these IF transformers. Again, tuning for amplitude and symmetry. So I'll get this all attached and we'll take a look at the spectrum analyzer here in just a moment. After working with the IF section for a while, this is about the best balance for this radio receiver. So it has reasonable width and reasonable amplitude. So what I'll do is I'll move the marker down 6 dB, and let's take a look at the width here, audio-wise. So what I'll do is we'll take the frequency, which is 456.0 kilohertz, take away where I've moved the marker now to, which is 452.720. 452.72 equals 3.28 kilohertz. So that's from the center line to one side. So that's what we're going to be listening to, and the total width will be times 2, which is 6.56, which is to be expected for this radio receiver. So not too bad. It's not going to be crazy high fidelity or anything like that, but it's not really super tight communications quality, and it's not really high fidelity. It's just kind of a nice balance. And it's got pretty decent amplitude in the IF section, so yeah, this should be a pretty decent sounding radio receiver once it's all back in the cabinet and everything. And the cabinet makes a big deal with the sound too. As you noted with the Stromberg Carlson, most of these radios, when you put the speakers back in the cabinets, they sound pretty fantastic. I'm ready to do the AM broadcast band alignment. I've put the bottom pan back on, so I imagine it's dragged the oscillator just a little bit. I haven't put the two capacitors back in here because honestly the ones that came out of this they're dented up and they're ugly. And the chassis just looks too nice to put those ugly old caps in, so I'll have to locate some nice looking caps and put them in. I'm not too concerned about that. They're not really doing anything anyways. They're just pretty much at this point stopping dust from going down into the bottom. So I have my signal generator set to 1600 AM, and that's one of the alignment points. So I have to align it at 1600 AM, which is right here. So to you, it's going to look like the pointer is off because you're looking at this on an angle, but I'll tell you if it's, on alignment or not. So one of the alignment points is 1600 AM, and the other alignment point is 600 AM. So I have to go between the two to make sure that the dial tracking is correct. So I'm not sure how much any of them have moved, but we'll find that out right now. So I have my signal generator set to 1600 AM at this point, so I can move this, and you can also look at the eye and you'll see when I'm right on frequency here. So I'm looking for maximum closure, and that tells me if I'm on frequency or not. And it is a ways off, so it's supposed to be down here. To you in the camera, it looks like about 4 bars away, but really it's only about 1, looking at it straight on. So I need to move that over. So I'll put that right at 1600. That's the first thing I need to do. So that's right on the 1600 mark right now, and you can see I don't hear a tone. So now I need to use my piece of paper here, which is my alignment paper, and you'll see here it says 1600 kilocycle oscillator aligning, so it's this one right here. So I will tip the chassis forward, and that's that alignment point right down in there. So I will put this on here. I'm doing this in the camera. Now I know nothing on the top side of the chassis is live, and these are not live at all. So if you're ever unsure about something like that when you're doing an alignment, definitely don't hold the alignment tool with your bare hands, all right? So again, if you're following along, you're doing so at your own risk. So I need to turn this until I get maximum closure of this eye, and that'll tell me when I'm on frequency. So here we go. I'll turn the volume up a little bit too. So I passed it, so I need to back up now. It's actually hearing a radio station in there as well, it sounds like. Right about there. So now what you do is you rock the tuning gang each side, and that's right on. So now the next alignment point is 600 AM. And if I have to move that, this is the 600 kilohertz alignment point right here, and that would be right below those wires right down there. I don't know if you can see that anyways. It's right below that, those white wires. So what I'll do is I will go to 1600 AM. I move this right now because I grabbed the tuning dial. But so now what I need to do is put my signal generator to 600 AM. So 600 kilohertz. So now I can move this down. It's a little bit low, so I could adjust that right now. So the alignment point is right in here. You hear it receiving a radio station. So again, looking at the eye, I'm looking for maximum closure. Right there. So now, rock the tuning gang. It's right at 600. So now I'm going to bring this back up to the top of the band. I'll just go to 1.6 megahertz here again, which is right here. And that's pretty much spot on. So now let's check the dial alignment at 1 megahertz. So I'll go 1 megahertz, and we'll see how well it's doing here. And that's spot on. So to my eye, it's right on top of 1 megahertz. So the dial tracking is doing okay. So now what I want to do is I want to peak up the antenna section on this. So we've done both the high end, all right? So this is the 1600 and the 600 kilocycles. So now I need to adjust the antenna aligning at 1600 kilocycles again. So that's this adjustment point right behind this one. So you got to be careful you don't touch the wrong one, or you're going to have to redo your alignment again. So I'll go back up to 1.6 megahertz or 1600 kilohertz. All right. Now what I'm doing is I'm going to be tuning this for a peak. All right. So I will pop this in here like so, and we're just looking for a peak. So you can see I've detuned it now, and I've passed it again. So it was pretty much peaked up. Right there. And that's it for the AM broadcast band alignment. And the other bands are just pretty much the same thing. So set the signal generator and align the dial. So now the dial tracking is correct and the antenna portion is peaked up for the AM broadcast band. And that's one done. So I just have two more to go. I'm going to put this thing back in the cabinet and we'll take a listen to it. We'll see how well this thing receives. Hook it up to an antenna, listen to the shortwave bands and everything. Here's a look at the radio all back together and ready for us to listen to. So I have to have the camera on this angle just because the dial glass is so incredibly reflective. You can see everything in that dial glass. So there's a look at the radio. You can see the presets down here. They all work. Of course, all the stations are wrong. Right now it's on manual, but that whole selection thing works very well. So as soon as you click that off of manual, it's just preset radio stations, and that's what that little tab in the back side of the radio with all those little adjustments were for. So that works very well. Again, all the stations are all wrong, but that's okay. I imagine I'll probably end up making some new little decals for in behind there, or decals, however you want to say that. So what I'm going to do is zoom on in to the face of the radio here, and it looks pretty reflection free at this angle, so I'm not doing too bad. So what I'm going to do is I'm going to situate the microphone right at the speaker, and then what we'll do is we'll cruise around and listen to what's out there. So I have to say, honestly, this radio dial, when the lights are out, looks magic. I can really see, as a child, maybe back in the 30s or 40s, looking at this radio dial and just awe. It really does stand out. The dial is just absolutely fantastic looking. There's just no other words for this radio dial. So this dial is worth the entire radio's restoration alone. It really is. So what I'm going to do is I'm going to adjust the lighting in here and try and make it look like we're looking at this in the dark, and we'll cruise around the bands. With no lights on, I can focus straight down onto the dial, so that worked out very well. I'm going to sound a little bit distant because the microphone is focused on the speaker of the radio. So the dial itself is just lit by those lights on each side. There's no lighting in the background shining on the dial at all. So this is just total radio. And as you can see, that dial is just something else. Okay, so here we go. There's not going to be many conditions right now because it's early in the day, so the atmospheric conditions are out, so it's going to be, the radio stations aren't going to be, on top of each other like normal here. So I'll turn this up, make sure I'm not going too loud.
And therefore, what we have to discover is what that purpose is.
Chemistry of teams and how important chemistry of teams.
Interior Health says its impact.
Take up for good keys.
States by 16% over the next quickly as I am for all of them. They're not adequate.
Yeah. Well, the bottom line is you just nailed it with
The way eastbound.
It's emerging across the globe. We know.
Listening to Halford.
Tyreek Hill lined up.
The case site for the evening, a snowboarder was.
Area says the province does not appear.
today. You do. If you've been diagnosed.
And if you're a superhero, do.
Why.org to see if you qualify. December.
Aquí están.
History.
So you can see the upper end of the band is a little bit more active than the lower end right now, but not bad. A lot of local stations in there. So that is the AM broadcast band. If I was listening to this around midnight, let's turn that down. If I was listening to this around midnight, you can't move the dial just millimeters without hearing another station. Like in the other videos with my other radio receivers, this is, it receives exceptionally well. So what you're hearing is just mostly local radio stations, and really there aren't a whole lot of them. So let's see here. Let's go to the next band. Let's try this band here. There's the time signal at 5 megahertz. Side band. Meter band. Lots of side band action.
COVID shot break.
that's it. This is pretty quiet down here. Top end of the broadcast band. So let's try this band down here, which is the highest frequency, goes from 5.5 megacycles all the way to 18.
컴퓨터에 무단으로 보다 위험한 대응을 하지 않아から市内の学校や편의점에서 파일기를
Time signal at 10 megahertz.
En este reporte todo lo que es el lo que está funcionando
is having more of a K-shaped recovery, but certainly
There you go. Here's an example of how the preset radio station selector works here. So I'll just quickly move through the frequencies and I'll come back. Again, all of these radio stations are incorrect, so I'll have to make new tabs for this for the local radio stations. They're really just little paper inserts. If I just press on them, they'll pop right out. So very easy to make, probably just print something up on the laser printer. So at any rate, what I'll do is I'll quickly move through this and give you an example, and I'll come back to manual again.
Changing your life. The U.S. Coast activity. I think if there's one letter,
Yeah, it was nutty.
it's probably that. The 980 originated from Ketchikan, Alaska. Tomorrow,
So there you go. They all work very well. They're all pre-programmable from the backside. So now here's something very interesting about this that you would need to know is this is preset number 1, 2, 3, 4, and 5 on the backside. And you can only program a certain range of frequencies for each one of these windows. So this being the lowest end of the band and this being the highest end of the band. And if I remember correctly, I think Como is 1000. So that wouldn't even work down here, right? So the little tabs are, even in the wrong windows. So whoever did this didn't put them in the correct windows here, but at any rate, this here will start at 5:50 a.m. and it only has a very small range at the bottom end of the band, and it slowly works its way up to 1600 a.m. here. There are two adjustments on the backside. One is called the oscillator adjustment and one is called the detector adjustment. The oscillator adjustment tunes the frequency that you want to select for each window, and the detector adjustment just peaks up the sensitivity at that frequency. So you tune to your radio station with the oscillator adjustment, and then you tune for maximum signal using the eye on the radio receiver here. So you tune for maximum closure with the detector adjustment, and then you move on to the next one and set them all up like that. It's really quite a simple process. Here are some final thoughts and tips regarding the restoration of this radio receiver. If you find that these tips may benefit you, feel free to use them. So first of all, I'll talk about the finalization of this chassis. You can see I've put the tag back on, and I've also found some capacitors that work very well with the theme of the radio receiver here. So first of all, I came across some really nice looking aluminum can style capacitors. They stood a little bit taller. I put them on the chassis and it just didn't work. So I kept looking around and then I found these. So I put them on the chassis and it just works. So if you notice, it fits in. Everything that stands up is a darker color. So it just blends right in. They're low enough that they don't block the view of the rectifier tubes. And you can see it, you know, it just fits in with everything that's dark on the back side of the radio. So that worked out very, very well. I'm very happy that I came across these. So these are now installed in the chassis. Again, these are just dummy capacitors. They're not hooked up or anything. They're basically just there for, you know, the looks. That's it. You may notice that I've changed this pipe here on the wiring, and I've also added some Teflon jacket. So I have a bunch of Teflon coax, and I took the jacket off and put a cut down the side of the jacket and clipped it over. I've tightened one end of the jacket in between this bracket here, and I have a small little piece of Gorilla Tape that I'm using to hold the other end, and it works very, very well. The reason I've done this is that I filed the other side here. So I filed all of this metal, and even though it was filed, I could tell after all of the tuning and, you know, working with setting up the eye tube, I moved the dial around a whole lot. I could tell that this was even starting to wear on the other pipe. I'm thinking that's no good. So this is a real design flaw from DeForest. They should have had basically like two little wings that stick off that would bend down to guide the wiring up, is what really should have been done. One here and one down here. So at any rate, what I'll do is I'll turn this here, and as you can see, this Teflon coax, it feels like it's a waxed surface. It's very, very smooth, very, very slick, and it just guides the harness up over that. That's at the dial stop right there. It can't go any farther. So it guides it over that. Nice rounded edge, works very well. And I've used some smaller Teflon jacket down at the bottom here. I've done the same thing right down here. So as this is turning around, see if I can get this all into the... and I've also put some Gorilla Tape down at the bottom here, and I've put some wax on the surface, and this is as slick as ice. So now when this comes down here, you can see it just guides over that little piece of Teflon shielding, or the Teflon jacket, and there's just, you don't feel any resistance in the dial or anything. So that worked out very, very well. So if you're going to restore one of these radio receivers, it's probably something that you're going to want to do. Again, I've moved this dial a lot during the setup procedure of adding this one tube down here, the control tube for the eye tube up here. So I wanted to match the eye tube to the reception of the radio with everything working just, you know, at its optimum. So I moved the dial around, and I had my signal generator attached to this, and I would vary the signal coming in and out and compare that to what's on the band. And, there's quite a bit of time setting that eye tube up, setting up the DC amplifier down there. So because I moved this around so much from end to end, on the original pipe, I had noticed that it had started to wear already from the metal area here. And that's just no good. So I thought, nope, I'm going to change that. So I put a piece of heat shrink at the end of this silicon coated piping. The heat shrink won't stay on the silicon pipe. So what you need to do is basically you shrink it down onto the silicon pipe, and it'll very easily slide off. You put some super glue on the silicon pipe, and then what you do is you pop it back in and very quickly move it down, and it sets. And that works very well for that application there. You can see it won't come off the pipe now, and it's just right at the end. So the reason that this is here is so the actual fibrous pipe will fray if you don't have this here, right? Because if it's going to be running up and, over top of this all the time, it will actually fray the pipe. So this just guides this over onto the pipe. That's all that does. All right, this is more important for down at the bottom end here because it will rub on that bottom little pad down there just a little bit. Again, they should have notched this. They should have notched this out, and this should have a little wing here. It would have been fine. So kind of odd. As I say, this is probably one of their earlier designs. I honestly have to say about this design, the radio works fantastic for what it is. Yes, it's a single conversion super heterodyne. You know, you've got the oscillator coils really close to the antenna coils, and there are image frequencies on the in the shortwave band, but it's just, I look at it as it adds character to the radio. That's all it does. It's just it's what the radio is. So this radio right now, I would honestly say probably works better than it came from the factory. Some of the values on the underside of the chassis regarding the screen grid voltages for the the IF amplifier and the other the detector, the first detector here, or if you like mixer oscillator, that's been critiqued and everything. So there's a lot of things that have been done. I could go on and on and on about this restoration, but it's, you got to draw the line somewhere, right? On the front of the radio, you'll think that because this is somewhat of a pinch roller in the bottom, and when you're rotating this, you can see how it rotates a little wheel in here and it moves this around. Now, if you clean this off, you might think that should probably be dry for the best grabbing. That's not true. It needs to actually be lubricated. If not, it'll grab so tight that the gear reduction portion won't work. What'll happen is the gear reduction will slip in the little ball reduction unit back here. So this definitely needs grease. And what I use is a silicone grease on here. This isn't a standard grease. It's the stuff that you would normally find for brakes. All right. So it's a silicone grease, high heat grease. Works really good, and it stays. It doesn't really harden up and get crusty like the other grease. So this here is a fibrous gear. Be very careful if you're going to try and turn anything. Make sure that you don't try and use this to turn anything. I don't know if you can see it. You can tell just by looking at it already that it's a fibrous gear. So be very careful around this. You don't want to put any type of a lubrication on this. You want to keep that fibrous gear dry. If you start putting things like oil or lubrication on here, chances are over time it's going to break down that fiber. It's going to make it soft. So you definitely need to be very careful about that. No grease on these gears. So this gear here turns very easy, right? Because there's no detent, there's no little ratcheting system in this one little switch up here. So there's no reason that this is going to need any type of lubrication on any of these gears. It's just it turns very, very easy. The only, I guess you could say, friction is the actual ball, the detent ball that's on this cam behind this gear, but that's attached directly to this gear, so there is really no friction here. So be very careful with that. You can see I've installed the antenna transformer, the actual shell, and I just put it back on. It's just a dummy shell. There's nothing in there. That notch filter is out of there. Definitely don't want that thing in line. The dial cleaned up very, very nice, as you can see. So that worked out very well. There are some minor imperfections in the back plane. There's one very small imperfection in the paint here, but this is outside the view, so you can't even see that. And I can tell, I think I mentioned this right in the beginning, there's a very, very small kind of little, it almost looks like a glass chip in the bottom here. And it's a rounded chip. So it's not going to spread up into the dial, which I'm very, very thankful for. And again, that's outside the view. So very thankful about that. So really what's in view looks pretty much perfect. All the paint on this dial is just spot on. Under here, you're going to definitely want to put a little bit of lubrication here. There's a little brass collar in the back that sits up against the control. You can use that silicone grease that I talked about earlier. For this, that will work just fine. So this here is its own control again for the the different lights and it selects the different bands, right? And then this is just a spacer here. Always put a little dot of lubrication. I use a light synthetic oil right where the shaft goes into the potentiometer, and you'll notice that there's a little C-clip, and if you get the C-clip just right, so if you can see, I don't know if you can see the opening in the C-clip right there, there's a little opening. What I do is I squirt just a little dot of synthetic oil in there, and that keeps things nice and fluid. I would have shown you the restoration process of these variable resistors, but it's going to add a lot more time to this as well. Basically, the wiper is in a steel band, and it presses the steel band around a fixed carbon track. So the steel band is fixed, and it's just this wiper that pushes the steel band onto the carbon track as it goes around. So really, there's very little wearing surface on the carbon track. It just comes and it touches the carbon as you rotate it around. The part that wears is there's a little fibrous, it's almost like a little stub in there that sticks off the actual center of the shaft, and it presses that piece of steel around in a kind of a circular fashion. So one day I'll go over those and I'll show you those. You got to keep those tracks dry. You got to be careful with that type of a potentiometer. One other thing is that they've printed basically the carbon onto cardboard. So you have to be very, very, very careful. If you take an air compressor and blow that, the cardboard will just blow right out of there and it's gone. You've just destroyed the carbon track. So definitely take note of that. You have to be very careful with the potentiometers, with that steel band that moves around in there. I can't stress that enough. If you take the carbon track off of one of these things, you're going to have a very bad day, especially if you a specialized control like what's in this radio here. So one final thought on restorations. Here's something. A lot of people are pretty hard on themselves with their own restorations. And yeah, I'm guilty of that myself. All right. So I've come to the point to where there's a balance. This restoration here, I look at it, okay, so if this is for myself or for somebody else, would they appreciate what's done? Is basically how I judge what I'm doing. Now, there are always people that are going to say, oh, you should have repainted or replated the chassis and you shouldn't have painted it. And, you should have the aluminum cans just exactly the same way they are. No, I shouldn't. You know why? Because I like this, and this is personalized for myself. And it's the same with your restorations. When you're doing a restoration for yourself, just feel comfortable about what you're doing for you. Remember, you're doing the restoration for yourself, not for the other guy. So if you're doing something for yourself, don't be too hard on yourself. Don't beat yourself up over these things. Just, if you feel good about what you're doing, just do it. Just go through with it. Now, this changes, of course, if you're doing a restoration for somebody else. Of course, it's their rules at that point. If they say, I want aluminum cans, you're going to be putting aluminum cans on there. But if you're doing something for yourself, like this is here for myself, I'm doing what I feel looks good and what really, matches on the chassis. Some people would be even against adding that tube in there, right? Well, there's a hole for it. That's a perfect hole, and it's got the Robertson screws. And it's almost like it was, somebody knew what was going to happen in the future, and they just punched an extra hole there. So the 6X6s again are just, they're gone, and the ones that are still around have burnt targets, and usually they're used. If you have a stash of 6X6 eye tubes that are brand new, you're sitting on a pot of gold, let me tell you that. So the 6AF6 that I've used in here is, very commonly available, and the circuit that's added is very robust, so I can just grab another 6AF6 any old time, put it in, and I have the same display as the 6X6. It even, it's using the biasing for the eye tube as well, so I left the biasing in here. So the normal 6E5s, they don't have a very wide shadow angle when it's open. Well, since the tube is biased negative, it pulls the angle wide open. That's why you see such a big area in that eye tube that deflects. And that's why also you'll see that it's not incredibly bright, because the cathode of the tube is lifted off ground. At any rate, I'll make a dedicated video to adapting these type of tubes to different types of radio receivers and things like that here in the future. So as I'm trying to say here, is just do what makes you feel good. I'm very happy with the result of this restoration. And if you were to do a restoration and I was to look at it, chances are, I'd look at it if you did something like this and I'd be just absolutely fine with it. I'm not that picky about, having the aluminum shells on and replating the chassis and doing all that kind of stuff. I'm looking at the future. I'm thinking, okay, the chassis itself is now got paint on it, so it's going to really last a long time. The surface was prepped by sandblasting, so the paint has got a really good bite onto the surface. You can see I've put the bottom metal pan on. I've put the pan on, right, which is really tight on this paint, pressed it on, and then you saw the last video shot, and then of course now it's out, and I've taken the pan off one more time, of course, to put these in, and you put the tag on, make sure no wiring is behind the screws and things like that. The paint isn't even scratched underneath this. There's no paint missing at all, and that pan just squishes on there tight. No paint came off whatsoever. So I'm very happy with the finish. And so don't feel, shy to do that. Don't feel that, get caught up in that. Should I replate it? Should I do this? If you find something that works, do what makes you feel comfortable. Don't beat yourself up over this kind of stuff. Just enjoy the restoration. You'll find that if you're too hard on yourself through restorations like this, you'll burn out. You'll find yourself going, I don't want to do these things anymore, because you get too hard on yourself. So the whole idea is to enjoy this hobby, have fun with it, do the best you can, and that's where it's at. Take care. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So there'll be a lot of repairs, restorations, a lot of circuitry design with modern and antique electronics. So if you haven't subscribed, now would be a good time to do that as well. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, and gaining access to many of my personal electronic inventions and designs, some of those devices you've seen in this video today, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll also pin the link at the top of the comments section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.